All right, stream is up. Let's get the chat working. Let's see, reload, and then the YouTube chat is always the the last one to work with my little app here. Let me just figure this out. 1 second. All right, I think that's working. Let me just test. All right, yeah, it looks good. All right, so we are back streaming on a Monday, which is different than usual, or Monday afternoon. Hey, how's it going? Welcome. That was fast. So yeah, I'm just continuing where I left off yesterday, doing some lighting stuff. I actually don't really have a plan for today, so I'm gonna kind of wing it, I think. But we got shadows working yesterday, at least kind of a rough implementation of them. They look a bit bad up close. They're very pixelated. But they're at least working. But I want to do other lighting as well. So I want to add point lights. I might consider doing a deferred renderer today as an optimization. So we'll see how that goes. Thanks. Appreciate it. So yeah, I have to do some stuff for Mac as well. Because yesterday, basically I added support for texture arrays into the engine. And I got it working on OpenGL and DirectX 11, but I need to get it working on Mac as well with Metal. So I need to do that before I forget. Otherwise, I'll forget and then things will break. So yeah, we'll get that in as well. So let me see. Can I get my Mac up? See, I have a little remote desktop to my MacBook. So we can hopefully test some Mac code. But yeah, basically texture arrays, if I take a graphics capture of the game, I can kind of show what I'm using them for. So here is, let's just take a capture of the frame. Right here looks good. Yeah, so basically I have this on the left side. It's probably hard to see on the live stream because it's so small. But I have a shadow pass for rendering basically the shadow map for the lighting. So like each of these is the depth buffer. So it's like looking from the sun's perspective. And here's like one of the houses, and then here's one of the houses. And then the next step back is a bit further out. We can normalize this. And the interesting thing about this is rendering into a texture array. So it's actually only one texture being used, but multiple array slices, which makes indexing it in the shader, I guess, more efficient. And also just makes it a bit easier to reason about what's happening. So I need to get support for these in Metal. So that should be interesting to figure out. Nice. Yeah, I actually use SDB image as well. I know the title says no libraries, but I do use SDB image currently for image loading, like PNGs and JPEGs and stuff. Yeah, I assume GLFW is for OpenGL, right? But yeah, anyway, so Metal. This should be interesting to figure out. So let me just make a simple empty project. Make it like texture arrays. This will be the name of my new project to test my texture array stuff. And let me just run this with Metal attached, just to make sure Metal's working. I saw that, yeah, he started streaming again. Sean Barrett, right? Yeah. Yeah, if anyone here wants to watch the real deal, you can go to Sean Barrett's stream. He's a pretty good programmer. But yeah, so texture arrays. I'm just gonna do test in this project just because it's a simpler renderer, which makes it easier to do testing. Oh, I'm on Mac. That's right. My keybinds are all different. So we'll have a GFX render target. So RT texture array. And we will just do some stuff in the init function. Sure. So if we just create like a 256 by 256 with this will create us basically a texture render target, and then we'll just render into this down at the bottom. Oops, not targets. This is no, this is just a remote desktop into my MacBook. Because I'm going to be using Windows for the most part today, so I'm on Windows. But I need to get some stuff working on my Mac, like my Metal graphics backend. So I have a remote desktop just into I have my MacBook off to the left. It just allows me to stream without like having multiple computers set up through some crazy capture card or something. So that's how I do that. Sorry if I missed a question. Do you store per frame mesh transform data inside the GPU local memory or host visible memory? Well, my renderer is really simple right now. So right now I just upload it as like a I upload the model view projection matrix every time I do a draw command, like a render command. I can show that in a second, maybe. Let me get some boilerplate code. So I'm not doing anything fancy yet because my renderer is like really simple. I don't actually have a formal renderer in the conventional sense. So like I have my graphics abstraction layer, but this is essentially like a graphics API. I don't know what's going on with my mouse, but it's up to each game to implement its own renderer basically. So I can go as simple or as complicated as I want, but I would have to write the renderer for each game. Like, for example, like with a 3D game, you have a bunch of materials and models and meshes. You'll have like rigged meshes for animations and stuff. You want to do probably culling and all this, maybe like streaming and textures and stuff. But like in a 2D game, I wouldn't need any of that. So my idea is I don't want that to be a concept of the engine. I want that to be a concept of the game. And then games that use that would implement, you know, these higher level systems. So yeah, I have like, I have the basic infrastructure to actually like do stuff on the GPU, but it's like up to the game to implement it. So yeah, that's how that works in my engine. All right, so this should render a red cube into the render target. So if I run this, hopefully I don't get a compile issue. We don't see anything, of course, because I'll need to go into Xcode. And start a debugging session. How do you even do this? Debug executable. And we need to find where this project is. Projects. What do I call this? Texture arrays. Runtime. Oops. Output. Runtime. Okay. And how do I do the debug? How do I do the capture for this? I don't remember how to do this. It's been a while since I've done the metal stuff. The game's not running. There it is. All right, so if I take a metal capture, and then, all right, cool. So let's see. I have, here we go. Here's my render target with the texture here. I'm not used to the Xcode graphics debugger. So this is fun. But here's my one-dimensional, or I guess two-dimensional, non-arrayed, so single image texture. So hopefully this is easy. I actually don't know how to do this in metal, so I'm gonna have to figure this out. Let's close this. Okay, so what we need to do is up here we'll add some depth to this. We'll add like three layers maybe for now, and then instead of doing a single one of these, we'll iterate over it. Is the music too loud? Let me turn the music down. I don't want to be like overshadowed by the RuneScape music in the background. I don't know. Should be good enough. Yeah, so we'll have this loop over. And we will just say it binds the target at this index. So this is like our layer. And then we'll have like a little just array of colors so I can see each one is different. All right. Oh my gosh. See, my remote desktop's like broken. Now it's like trying to do some crazy clicking thing. So if I render this, I think this will break. Well, it didn't break. It just doesn't work probably. So let's see. Oops. Back to Xcode. Let's run this again. And we'll get another graphics capture. And we'll see. What do we have? Yeah, so we got blue in here. So it like, here we go. So we have our red, green, blue getting rendered into this texture. But it's rendering, it's like overwriting the previous state, right? So it's like the input is red, now it's green, and it's blue. So this isn't what we want. So we need to actually like do the texture array part of this. So we can close this and that. So we will need in the init function for metal. Let's go down to the metal code. Where is this? Backend GFX metal. So in this render target init, I assume it's a property of the texture descriptor. So what is a texture descriptor actually defined as? How do I go here? Send me here. So what do we have on this thing? Width, height, depth. The depth of the texture to create. The default is 1. When allocating texture types other than 3D, depth must be 1. Array length. Yeah, see, this is what we want. The number of array elements to allocate, the default is 1. When allocating any non-array texture type array has to be 1. Otherwise, it's something greater than 1 or less than 248. So the max is 2048 of these things. So we will have array length. Is there anything else I need to think about? I don't think so. And this is what type? An NSU integer. Okay. I don't know what DOD is. Megastruct or ECS. Hey, how's it going? Welcome back. You are a loyal viewer. You are in here all the time. That's impressive. What do I think of DOD, Megastruct, ECS? I don't know what DOD is. Maybe if you expand the acronym, I can recognize it. But megastruct is like the idea that an entity struct is just like every entity just stores its data in this megastruct, and then you just represent every entity as the same struct. And that's an interesting approach. Like that's what like Casey does, right? In Handmade Hero. Oh, data-oriented design. Yeah, I got it. Yeah, that's an interesting thing. And ECS is interesting because like ECS and then the megastruct are kind of like opposite ends of the spectrum for laying out your memory. Yeah, I think they're interesting. So my engine doesn't use ECS. I guess I'm maybe more on the megastruct side of things, but I also support inheritance. So I'm kind of, my engine supports, I've implemented kind of the classic inheritance-based entity system where you just have like structs for each type of entity, and then you can inherit structs or inherit from other entities. But I don't do it like as simply as like the basic implementation. So I do like bucket all of my entity types into contiguous arrays of data. So that like, I'm like, I have like a hybrid system where I have decent cache efficiency. I'm not just allocating all the time, right? Like I allocate up front and then I just kind of hand out entities based on like a pool allocator system. And I have a fancy thing going on in my build pipeline that like deals with inheritance without having to use like virtual functions. I can use virtual functions, but I don't have to. So most functions don't use them. So yeah, I don't know. I think it's interesting. There's so many ways to do entity systems. It's kind of up to you, I guess. Like what are your needs in your engine? Descriptor. Hey, how's it going? Welcome everyone. That's good. Good to maintain interest. All right, so I think it's almost as easy just adding a layer count to this. Layers. Which is, this is why the metal API is actually really nice. Because you just add stuff to this. Now when I bind, I think I need to also do something special. Nice. Yeah, how do you even start making a project like this? So you don't start with a big project. You start with a small project and then you make it bigger over time. So like my engine started out very simple. And like actually, so this engine is like an evolution of stuff I worked on previously. So like I've been working in this specific code base for about 2 years. Like this is kind of like a 2-year effort, not full time. So I only work on the weekends and stuff. But this 2 years, but I've had other games before this where I was like making the engine as part of the game. So I worked on stuff for a few years prior, but it wasn't like a general purpose engine. It was just like the game also implemented its engine as like part of the game. So they're very tightly coupled. And I did a few of those. So I basically like learned how to create a game engine kind of from scratch. But then I decided that I was getting annoyed about not being able to do rapid prototyping of different game ideas. So I was like, I really should just make this general purpose. So then I took a step back and I was like, okay, what part of this can I remove? Like, which part of the engine is actually like part of the engine and which part is part of the game? So then I started this project where I have a clear like delineation between what is engine code, what is like build tool code, what is like game runtime code. But yeah, it didn't just start overnight. It was an evolution, and it's still evolving. Like, I'm a big fan of like malleable code. So like, you don't want your code to ever be completely fixed, right? Like, don't be afraid to change your code. Because otherwise you get stuck just kind of, wherever you are, you get stuck. So you don't want to be stuck. Hey, welcome everyone. Did I try C++ with Unreal? I actually never have used Unreal Engine. So the answer to that is no, I have not. I know the only stuff I know about Unreal Engine is like what I've heard from other people and like what I've seen in random YouTube videos. Which is maybe a problem because maybe I should. I know a bit of Python, yeah. I have like a working ability with Python. Sorry, let me get some of these things in first. Oh, this is interesting. See, like some of these things are versioned, which is fun. Available macOS 10 8.1. 10 is really old, so this is fine. Sorry, I need a table of these things in my engine. So this is NSU integer. I don't want to miss questions, but I also want to code. Style guide. Yeah, so yeah, like you observed, I have very C-like coding style. And that's just, most of that is because it's from, like, I've inherited a lot of my style from the company I used to work at, where their code base was also very C-like. Here, sorry, I just need to make a little lookup table for these, where I map my engine's texture types into Metal's texture types. Let's see. So I need GFX texture type. But otherwise, like, all my variable naming and kind of indentation white space style. See, like, I need to remove this texture array concept for 3D because this isn't actually a thing. So I should come in and do that at some point. So I basically just need these. Oops. My key bindings are different on Mac. This is annoying. All right, so what are these? We have this one, this one. Oh, a 2D array multi-sample. That's annoying. So we have 3D. 3D array doesn't exist, so I'll just put that there for now. And then we have cube. And then cube array. Do I miss my game development job? Not really, to be honest. It was all right. Sorry, let me get this. I don't know. It was okay. Texture types. It's hard. I'm like programming through a remote desktop, so I have like latency in my keyboard. All right. So let me. Missing GFX texture type. Oh my gosh, what's happening? Stop. This remote desktop tool needs some work. I don't know if I need a multi-sample version of this. I see multi-sample stuff in here though. Do I have my own net stack? So yeah, I can show that. I did write some network code. So I have like a network layer in my engine. And I've like implemented my own. So I'm using like the WinSock API on Windows. So you can see like for TCP socket, I'm using just like the socket, you know, stuff. Yeah, so I'm using the IOCT interface. I also have UDP implemented. And then like for POSIX, I'm using, I forget which header files these come from. It's like the sys.tcp header files and stuff. So I implement both TCP and UDP, but I've kind of abstracted it slightly. So like I just have the concept of a socket, a server, and a client. And then I have like a handshake thing built in to the engine just because I do that all the time. I didn't decide I was ready. You just kind of have to like do stuff. Because if you wait too long to do stuff, then you like never actually start. It's like I said earlier, you should embrace the fact that code is malleable. Because why is there a 2D multi-sample type as like a specific thing? Because like you're not going to write perfect code on the first try, right? It's just not practical to do that. But you'll learn a lot like on the journey of like trying to do stuff like this. So yeah, sorry, I'm like trying to answer chat and do this at the same time. Why does copy and paste only work sometimes? What is happening? Copy. This tool sucks. I want to go back to Windows. Okay, so I use this here. So we want to look up the, so I have these metal texture types, single sample, which would go to, I guess, texture type. So we need to steal some stuff from this. So we'll just steal this, and then I meant to steal this from DirectX. So I have this. And then this is here. So put that there. So I just need this one. And it doesn't like this for some reason. Texture type. Is this not? Oh, this is an enum of this type. I had my type wrong. Okay, so will I ever make tutorials? I'm not sure, actually. I might. That could be fun. I'm not like a very good teacher, though, so it's something I would need to work on. But maybe if I get inspired to do that, I might do that. The thing is, it's like hard to write a tutorial because there's so much content to cover. It ended up like Casey Moratori's Handmade Hero series, where he like did it for years. And it's like, well, at what point should I just point people to his tutorial versus like doing my own? Unless I have some like insight that I could add to make it more interesting. Okay, so that, oh my god, what is my cat doing? Stop! Don't get in the plant. Cat's like eating the plant. Please make tutorials. When you work on a complex project like this, how do you keep up with the huge file structure and directories you have? Yeah, so that's an interesting question. And I've gone back and forth on how I organize things. So yeah, there was a point in time where I used to like try and organize more than I do. So you can see like here's the Manta directory. So this is like the game engine library basically. So these are all just like these header source file modules, I call them, are just like little library things that you can just include into your game and then use them. So like there's like a threading API, there's a like a simplex, so for random noise functions. And there's like obviously fonts for rendering text. Oh, my cat is so annoying. He's like gonna knock over my plant. But you can see I just have decided to just dump these into this one folder. So there's just a lot of files in here. But like I just try to keep things as obvious as possible, like what they do, right? Like, so I have text here, so this is like a rich text system. So it supports UTF-8. It supports like highlighting and stuff. So this is like my text system. But I just try to keep things simple. And like, so like my build tool, which runs before the game compiles, this is its own separate little program and it has stuff in here. And then like the core is like just core library type stuff. So this is like things that you would expect to get from like the C++ standard library if you were using it. So like I have a hash map implementation in here. I have a factory. I have like a list. And my list is like the standard vector. I don't like the name vector, so I named it list. But I have like math functions and stuff. So like it looks complicated and it definitely is, but it's also, each thing is kind of like responsible for its own stuff. No, I'm not using VM. I'm just remote desktoping into my MacBook, which is off to the left on my desk here. It's just so you can see what I'm doing on my Mac. I just have a bit of Mac stuff to clean up today. So I need to get these array textures to work, and then I'm going to move on with some other stuff this afternoon. But yeah, this is just running on a Mac. And I'm using Objective-C++ to bridge between like Metal's C, Objective-C, and then my engine. Which part of the engine force do you think C++ actually works? I don't know. I don't really think there's part of the engine that forced that. I think just like doing a lot of the low-level stuff really helped me get good at like memory layout type things and like using pointers and that sort of intuition. But this project didn't necessarily push those boundaries. Okay, sorry, let me think about this for a second. So I need to figure out how to actually attach. This is what I was figuring out with DirectX yesterday. There's like 3 things I do. So like debugging. Usually my first approach is to do like, and this is, maybe people think this is nasty, but I'll do like print debugging. Usually is my first approach, just because it's like easy to throw a print in there and see what happens. And like generally most problems, I kind of know what the flow should be. So if I see a print value that isn't what I expect, then it's like, okay, I can hone in on the problem very quickly. Obviously for problems that are more complicated than that, I'll use the debugger. So like VS Code has a debugger you can use built in. So like I'll use that usually because it's just easy to use. But the VS Code debugger kind of sucks. So otherwise I'll use the Visual Studio debugger. And then for like runtime performance type stuff, for like graphics, I'll use like a graphics capture tool to do like actual analysis of what's happening on the GPU. So like RenderDoc is like a decent one. And then like CPU profiling. I don't really have too much going on for CPU profiling yet. But I have a built-in profiler module in the engine, which can get me like, I can time functions and then see like a little breakdown. So like I can kind of show what that looks like in my other project, what my profiler. Why isn't this running? Oh, his RenderDoc is open. I have not tried Zed. Yeah, so here's like the other game I'm working on. This is my Terraria clone game. I've shown it on stream a few times now. But I have a profiler built in to the engine as well. So I can like pause this by hitting F1. And I can like see, how much time different functions take. So like you can see these frames are kind of, I'm in a debug build, so it's worse than it usually is, but some of these frames are kind of hot in terms of how much work they're doing. But yeah, I've just some convenient stuff built in for that. Okay, so back to metal. I want to finish this up quickly if possible. And yeah, I have like macros that I just put in the top of the function that will like profile the scope, and it'll like capture the name of the function using like the built-in function name macros that come with the compilers. Okay, so when I attach a texture, how do I know which slot it's actually reading from? So wait, let me think what's happening. So state bound color slot gets set to the color texture. Why is it +1? What? Where's this ID coming from? Oh. Okay, so I get the texture ID. What do I do with that? So nil or metal texture. Oh, so I get a metal texture. How do I set it to use a specific, like, is there an MTL render pass descriptor dot color attachments array length? What is this structure? This is just a metal texture. How do I get it to set a specific? I used to work at Activision. Yeah, that's true. I mean, it depends. It depends how you define library to answer that question of how to do stuff without libraries. So like, obviously, to do stuff with the operating systems, like create windows and do threading, you will have to use the libraries that those operating systems provide you to do those things, because obviously, like, you need to communicate with the operating system. So like, if you just want to do stuff in C++ without any of these extra frameworks that you typically download, you would have to go to like if you're developing for Windows, right? You're gonna use the Windows header files to do stuff like create a window, do like the file system, do like audio and multi-threading. And then you'll need to look up the Microsoft documentation for how to use these header files to actually do this stuff. $15 files. No, it's a pretty big project at this point. Yeah. So what is the equivalent of, I need to do some Googling. Basically, again, this is like deja vu from yesterday, but I have in OpenGL bind targets. So basically, I'm implementing the metal backend of this version from OpenGL. So OpenGL, when you bind basically multi-layered textures as like a render target output. Yes, I know Tokyo Splift. Well, I don't know him personally, but I know of him. I've seen his live streams plenty of times. He's very entertaining. Oh my god, where is my Google? let's see what the Google AI tells me to do. So we have a render pass descriptor. We attach the color attachments, texture slice. So we need the slice here. And that's it, I believe. Oh, that's really convenient, actually. See, this is what's great. I love Metal. Look how easy this is. You just use this. Well, in theory, we'll see if this actually works. But I guess it's just, and that was at texture.slice. Attachment.slice. Okay. So it's like dot slice is equal to, I guess I'll need to do state bound color layer slot. So I'll do this. I'll need to do some extra state tracking for the slot. Beware of Sam Altman influence. And then the same would be true for the depth slot. So mtl render pass descriptor dot depth attachment dot slice equals this, but this would be the state bound depth layer. And then otherwise, we'll just set the slice equals 0. And this should be 0. And then I just need to cache these as values somewhere. So we'll need to plumb these through. So where do I state bound depth texture? So we'll need to have just a static, I guess U32 for now. Oops. So then everywhere we set this thing, did I copy? Didn't copy. All right, here we go. Oh my gosh. Half my hotkeys do not work. I'm dying over here. I just need to copy this. So this is binding textures for rendering into them. That's what I'm doing. State bound depth layer. And then here we go. So if we have color, then basically we do this. Paste that equals not equal to, should be layer, and I'll need to create a, I'm using the right click menu because my hotkeys aren't working. Yep, that's basically how it's done. Do you use source generators in your build system? If you mean like source as in like code generation, I do generate a bunch of code, yeah. And I can show that in a second, how that system works. But yeah, I generate a bunch of code for the, well, not a bunch of code. I just generate code for the entity system, and I generate code for graphics as well. So I have my own shader language in this engine, and my shader language does more than just translate shaders between the different shader languages. It also does some code generation for like, kind of like a cheap, a simple version of reflection based on the types used in my shader language. So I have that as a system in my engine as well. Okay, and then That should all be accounted for, so we just need to grab the layer here. And then I think this should work. So if we try rendering this, hopefully we don't fail. What's happening? Welcome back. Welcome to the stream. Working on arrayed textures right now, texture arrays. And I'm on Metal at the moment, so I'm on my Mac doing some fun texture array stuff. And I'm working through a remote desktop tool, so it's kind of a pain because it's like I have latency and my key bindings don't work, but we're getting there. In theory, I should have, let's see, uh-oh. Not quite working yet. So let's see what happened. Slice 0, slice 1, so that worked. It's not rendering into it though. Slice 2, that worked. So is it not initializing it with the enough slices maybe? How can I see the resource for this thing? I don't know how Xcode works. Yo, how's it going? Welcome back. Day 2. This is Xcode on Metal for Mac. So this is Metal. This is Apple's this is Apple's graphics debugger. Well, I guess this is their everything debugger. Banned. Where are my resources? How do I view my resources in this tool? View. Show. I don't know how to view the resources. Here we go. Can I just like view what this is? I think it's not getting the multiple textures. It actually is pretty good. I'm just not used to it. If you know how to see, like in render doc, you know, you can do a render capture. I basically want to find, how do I find like, see here's the texture, right? But I can go to the resource inspector and like select my, I guess all my random stuff here. And like I can view information about these things, you know? Like how many sub resources does it use? You know, all this crazy stuff. What's the equivalent of this on Xcode? I don't even know. I can't figure it out. I assume I'm not getting my extra slices. So let's see what's happening with that. So we'll kill this. I need to pay the $100 developer fee to view the resources. The $100 annual fee just to develop, just for the privilege of developing for their ecosystem. I need to pay them to be a developer for their ecosystem. Okay, what'd I mess up? Render target init. I thought I did this. So we create the color descriptor. The array length is layers. Was that not good enough? I assume that would be good enough. Oh, I'm not setting layers here, so I need to set that here. Layers. Layers. Where do I set layers equals 1? Maybe this was the problem. The draw call, yeah. You probably need to buy their same accessory. No, I don't know. I was just joking. Do you actually need to pay? That'd be crazy. You do need to pay. If you want to publish on the App Store, you definitely do need to pay. I know that. I don't think you have to pay for the tooling though. That'd be crazy. But who knows? So much work for less than 1% of Steam users. Yeah, that's a good point. That is a great point. the reason I'm supporting metal is I wanted to potentially do mobile, not mobile games necessarily, because I'm not too interested in mobile games, but I wanted to be able to use my engine to do like mobile apps potentially if I have like an idea for something. So if you want to do anything on iOS, you basically need to use metal nowadays. So like I have to implement metal just for that. So I figured I might as well just do it. That was the reasoning. And now I'm deep in this metal rabbit hole. Yeah, I think it's still the same. I think you still have to pay. Okay, so let's see. At the bottom, do I have textures? No, I still don't. Interesting indeed. Has data flow. So texture. Can I just view what this thing is? How do I get to this? Is there like just a giant list of... So here's the draw calls. Everything here is the draw call list. And here's like your fancy little graph. Memory maybe? Oh, here we go. Yeah, here we go. We have a texture 2D array. Oh, it does have 3 textures. So it was working. It just wasn't... it just wasn't showing it to me. So yeah, this is what I expect to see. I expect to see red, green, blue on each slice. It just wasn't showing that to me for some reason. I don't know what this X is doing here. It's like a little thing here. Okay. So this is working. It just wasn't showing that for some reason. It only shows you the first one. Okay, now we just need to make sure, oops. Now we just need to make sure we can actually sample this thing in a shader. So we need to add some support for that, most likely. So we will take a look at what that entails. So if I go to the generated shader code, output, generated shaders. We need a shader that actually uses this. So let's have like a little shader that can render a specific slice of an arrayed texture, a texture array. So we'll add a shader, new file, texture array dot shader, and we will have in this file include I'll just copy the default shader over. And just add a uniform or something. Texture color array. Take a float. Another uniform buffer. Or index would just be the layer, I guess. This is what we'll sample from. So sample texture 2D array. Array. And then that takes the uniforms. If I can type. It doesn't like this for some reason. Oh, this should be a texture 2D array type. So we just need to see if metal actually generates code for this. It does not. It doesn't know what this is. So what is the problem? Oops, wrong project. Why isn't it in here? So it just doesn't even know what this is. Did I typo this? Oh, I did typo this. That's funny. Okay, failed to compile metal bytecode. So metal doesn't know what this is. No matching member function sample. So what does sample need to be? Oh, I need to generate the code for this. So I'm just going to assume that the sample function for a texture array is like the same as it is in DirectX and OpenGL. So we probably just need to add another condition to the shader compiler for metal. So texture type 2D array does not exist in here apparently. These don't exist. What? Where is it? Is it token type? Where do I generate this? What is happening? Here we go. Intrinsic. I'm looking for the intrinsic. So I'm looking for this guy. See, I have too many types. So this guy needs its own condition, basically. Its own specific branch, because the sample function probably uses a vec3. So this would be what? This would be a float 3, and then need to add another comma for the next type. Parameter, print out the expression, and then we'll see if this is all that we needed. Hopefully it doesn't take a special kind of thing. Okay. Oh, I was dropping some frames again. Hopefully my internet can keep up. I pay $100 a month for internet that can't even that can't keep up with. Okay, so let me see. What is the metal? What is the metal sample array function? We're using the metal AI. So it is sample. Oh, see, it takes it as a separate parameter. Okay. Good to know. So this was wrong. This should actually be what it was. And then I don't need this. So this should work. Could we not spam emojis in the chat? Not that I care too much, but preferably not. Okay, so let's see. So this is metal shader code, by the way. If anyone here is not familiar with how metal code looks like, with what it looks like. So metal is an interesting language because you basically write C++ code for your shader code. So all of these like things are passed in as parameters. Yeah, I'm gonna remove these. Yeah, something happened. But yeah, so yeah, metal it looks like this. It's kind of crazy. So there's no global state really in metal. So you have to pass everything as function parameters all around the place. And all these things come in as parameters to the main function. So like your primitive ID and like your samplers and your textures, they're passed around as parameters. Then they're tagged by these attribute things. So that's how that works, which is kind of interesting. But yeah, so we need... What was I doing? I wasn't... What was the problem? I've lost my train of thought. What was I just doing? Oh, I was gonna actually use this shader now. That's what I was doing. I'm curious what the yeah, I'm curious what was the hard part, because maybe I can help you with that. Or at least point you in the right direction. Okay, so let's draw this thing. Sorry, I'm just kind of locked in here. All right, cool. So we see 3 textures, 3 colors. Yeah, don't forget to add GCC to your system path environment variables as well, because I don't know if it goes in there by default. So that's another thing to think about. All right, so arrayed render targets are now supported on Metal, which is pretty sweet. So I can get back to the lighting stuff in the main project. But first, let me just make sure I'm accounting for their size in the debug stuff. Where am I? Build. Source. Manta. Backend. Metal. So, let's see. This should be accounting for layers now. So everywhere I do this needs to account for... Oops. What happened? Okay, so yeah, everywhere I'm counting for that. Needs to... I need the depth one. All right, let me just push these changes. Because I'm happy with that. And we can get off of Metal. Get off of Mac. Thankfully. So I'm going to close this out. And we can go back to the actual game here, which should be fun. Oops, I hit connect. Now it's going to crash because I don't have a server running. The whole thing about using other libraries, I kind of want to tinker with OpenGL and stuff, and just everything I've tried never works. Yeah, so like, I'm not sure what to recommend for that, to be honest. It's not, so like, I don't know what libraries people use to just tinker with OpenGL. I assume GLFW, is that the one people use? Let me Google this. But the way these things normally work is like, is an open source multi-platform library for OpenGL. Yeah, so you probably download this. Where's like the release? You'd probably download this, right? So then you get the include header files. You should have like a binary in here though for this where maybe I thought they would have like a pre-built, just like a DLL that you can include statically. I don't know. I don't know where it is in here. Yeah, GLAD, is that the one? I don't know. I don't use this stuff, so. Let's go like the GitHub page. Typically these things, like you go to the releases, you would have like a pre-built binary that you can link to, unless you're going to compile it yourself. I guess these just supply the source code. Compiling the source is actually more annoying, I think, because then you have to like set it up to their thing. Interesting. Yeah. Yeah, like really, if you're a beginner, you should learn CMAKE probably. Because CMAKE, you know, CMAKE's kind of annoying to learn. But if you have CMAKE, it's easier to just add libraries and stuff, assuming that the project that you're including also has CMAKE stuff set up for it. Like you said, you have the CMAKE list file. It should all just kind of deal with itself correctly. And then, yeah, RayLib is another one people use. The shadows break at a distance. Yeah, I guess this is the annoying part with C++, is that the build system is kind of... There's a big learning curve to figuring out how to actually compile C++ code and like set up a build system. So like other languages don't really have this problem. Like with Java, for instance, it's like really easy to do Java because like you just have to have the Java runtime and then like you can just run Java code. But C++, like there are 3 compilers, 3 main ones. There's like a few other ones too. There's lots of versions of C++ and like different libraries, and you have to like, and you can link to libraries in different ways. You can do like static linking or like dynamic linking at runtime. So it's definitely not very beginner friendly. I think it's good to know though, like it's good to learn this stuff. All right, so yeah, this anyway, this is the current state of the project. I added shadows yesterday, and the shadows are rendering on the rat and the bus. So I added models and stuff last week, or potentially 2 weeks ago. I don't remember when that happened. So I want to actually start doing some more lighting stuff today. What's my favorite game? I don't know. Probably Minecraft, to be honest. Though I don't play Minecraft that often. I play Minecraft like once every like 2 years. So maybe that's not my favorite game. I don't really play games, to be honest. I like the Red Dead Redemption series from Rockstar because I like the story in those games. But that's also a game where you like play it once and then you know the story, so you don't really play it again. So I don't know. I don't really game too often. Yeah, make a Minecraft clone. See, I made a basic voxel renderer a few months ago. I don't know if it still compiles. Let me see. Let's do LLVM. We'll see if this compiles. I'm not sure if it still works. Oh no. Here, let me... fix this compile bug. Yeah, here we go. Here's my Minecraft, my voxel renderer, my Minecraft clone. This should have shadows too. Yeah, here they are. I think the shadows are broken though, because these don't look correct. They're like in the incorrect spot. So maybe I should turn the shadows off. Game Maker does not play. You play a lot of Terraria? No, I've actually really haven't played Terraria, which is kind of ironic because I have a Terraria clone. Yeah, the terrain gen is just 2D noise. This is really basic. I was just messing with rendering stuff at the time when I was doing this. Oh, I have like an LOD system as well. It's hard to tell on the stream probably, but the further away I get, it like does level of detail on the voxels. And the idea that it switches once like the screen size of the voxels like goes sub-pixel size, and it can combine them. And it does that multiple times, depending on the distance. So that's kind of fun. But there's nothing to this. It's literally just like I'm rendering blocks. This isn't portable. I don't know what the question was. You can write a batch script and just link the library manually. Is that what's not portable? I mean, a batch script can be portable. You just have to write like a shell script for POSIX systems. I haven't done LOD on the models yet. But yeah, anyway, what I want to do today is I want to do some more fun stuff with the lighting. So I want levels that have more complicated models in them so I can actually test the lighting. So we're going to find some models. Skyrim did not popularize LOD. That's been around for like as long as 3D graphics have been around. Pretty much like all games do level of detail. So 3D models, free OBJ. Yeah, I agree though. New platformers shouldn't really worry about cross-platform or CMAKE. I agree with that. So we need some models for stuff. Like we want, I just want to make a simple level in Blender, and we'll load this in as like our lighting test level. So let's go like low polygon, OBJ. Let's just find some models in here that look decent, and they just need to have materials that I can use for lighting, basically. So like this tree might be good because look, we have a specular map, translucence map, normal map, diffuse. Yeah, great. This works. Download this in 20 seconds. Let's get another one open. Oops. Minecraft free download. Let's see, building. We need like a building model. Or like, I don't know. file formats, OBJ, because that's the only file format I'm supporting currently. I will add support for FBX probably. Free. Why am I still searching building though? Oh my gosh. I hate this website. I don't know why I'm using this. Is this done? Yeah, so here we get our mango tree pack, OBJ, and download this. I agree. I agree with that. Here we go. We have 3 variants. This is nice. This is exactly what we want. So let's see. We need like a... I'm just going to create a little folder here in this. Test models, sure. Just so I can dump files into here. Because I'll need to do some manual patching on some of these probably. I'll try to do this quick because this isn't really... Oh, these are TGA textures. Oh, that's annoying. So I want to convert those. We'll just do one variation of tree for now. Tree. So we'll grab this guy. We'll edit its material. Okay, we can delete that. And the bump will be the normal map, because this looks like Specular. So we have diffuse, Specular, and then we'll also have a normal map for this guy. So we'll move that. Let's grab its textures. So what's diffuse is probably this one. Open with render doc. And I can export this as a PNG instead, just because I would rather have it as a PNG. PNG. And Specular map, we'll use this. Open with RenderDoc. And what else? Normal map. Okay. We need to do the bark. Maybe I should have named those leaves. Specular. People upload their assets for free. Motivate you to code. That's that's good. Bark Specular. I'll do this just for a couple models first, just so we can. We just need something that we can render, that I can do lighting calculations on. And what I need, the normal map. This should be the last one for the tree. And the tree should be fun because I can like animate the leaves maybe. Okay. Good enough. It should be leaves. Leaves. I'm just gonna call this tree. Tree. Open this guy. C# is probably easier, to be honest. Just because there's well, I don't know. I don't really have experience with C# game development, so actually I can't really answer that. My intuition is that C# would be easier because it's like a higher level language, but that doesn't always make things easier, so it's hard to say for sure. Don't make custom engines, to be honest. I agree with that. If you just want to make games, yeah, definitely don't do what I'm doing, because this is not the efficient way to make games. Okay, so close this, and this is the trunk. So this is bark color, bark normal, or bark specular, bark normal dot png, png. I'm just getting this to use the format that I have. So then, in theory, if we just import this guy into Blender now, test models, tree. This guy should have his materials assigned already. Let's see. Exactly. It's because I do this. I do it for fun, so it's fine. It's perfectly fine for me to do this. But I wouldn't recommend it. Interesting that the tree has no. Did I lose the opacity of the leaves? What happened? This thing has opacity, so I think it's just Blender being weird. Maybe I need to like change it in the material setting. But here's my tree. Let me scale this down. I sound like a wise old man. I don't have Vulkan supported yet, so I can't answer that. I have DirectX 11, OpenGL, and Metal fully supported, and I'm working on Vulkan, so it's not ready yet. I'm working very slowly on Vulkan because it's just been a low priority for me. So if we export this tree, let me make sure my coordinate system is correct. Because my tree is going to export and then it's going to be like oriented the wrong direction. But let me re-export this as... Because I want to triangulate this mesh and I want to make sure I get the... what is happening? Here it is. So then... I need to clean up my asset folder. Tree. Let me just add a tree model. So I need all of these. Let's copy these over to here. And then we will copy the model file, paste, tree. Just point it to the material and the model. And then we should load this in and hopefully see a tree. Oh, wrong project. All right, here's my tree. Looks pretty good actually, but it's on its side because I, unfortunately, I use different. My basis vectors for my coordinate system are different from Blender. So the classic problem where it's seeing Blender's up vector is my right vector. It appears. So I need my up vector from Blender to be positive z, I believe. So let's just trial and error this until we figure out what's the correct one. I can change where this is being exported now. Dev, Manta, projects, assets, tree. So up axis is, so if theirs is y, mine needs to be z, right? Then my forward axis is x. So let's try this one. What happened? Oh no. Blender changed my paths on me. There we go. That looks correct. That's a nice looking tree, if I have to say so. Look at that. It's a good looking tree. Minus the alpha blending problems with the leaves. Not very good looking. I'm not even sure how to solve that, to be honest. I know it's like sorting by depth maybe, but I don't know how to, it's like self-occluding, so like it looks fine from some angles. Unless I just turn off, I need to have like a harsher cutoff for my alpha, basically. So like if anything is less than, like I would need to change it to be in the depth shader for shadows, it would probably need to like cut off if it's less than 1, you know, now it's like, it's either visible or it's not. Oh, but now I can't see. Because of the equal sign. Something like this looks better. It's a little sharper. Arguably it looks worse from certain angles though. But maybe that's just how it is. Oh, and then because of the MIP mapping. Because of MIP mapping, I lose my leaves with distance. None of the guns cast shadows yet, or receive them. It's only the scene, like the level cast shadows at the moment. Okay. That looks fine though. I'll deal with the leaves later. So the leaves are using MIP mapping, and I'm like generating MIP maps in a custom way. So maybe it should be that leaves have like a fallback alpha value for the MIP maps, because right now it's like kind of blending into nothing. So I lose my leaf texture with distance. It doesn't look too great. But that's fine for now. All right, let's find another model. Let's just do this again. Let's find something that looks more like it belongs in a 3D level. Yeah, okay, so you're talking about this at the bottom. Yeah, so this is like a custom plugin I wrote. And I have the source for the plugin in the GitHub. So the GitHub link's in the description if you haven't seen it. And in this .manta folder, there's a VSC, so Visual Studio Code Manta extension. And the source for the extension is in this extension.javascript file. And basically, this is kind of a gross JavaScript program because I'm not a JavaScript programmer. But all these widgets are like defined here in this activate function. So like here's like the build widget that you see in the bottom left. But if I go into this function, I forget how this even works. I don't know what type a widget is, to be honest. What's this widget build run? Oh, it's you have to do this create status bar item from VS Code. So it's like a library you import. And then you have this function. So this gives you a status bar item, which is like anything in the status bar at the bottom. And then you can give that thing a command. You can give it text. You can give it a color. And then you have to push it to the context, like the VS Code context, workspace context. And then it should just show up in the bottom. And I have these like hooked up to commands. So when I click them, they do something. Like if I click the clean runtime cache, this is a command that deletes the runtime like output directory. So it will force me to rebuild like the game runtime. I'm using DirectX 11, OpenGL, and Metal currently. And I have a work in progress Vulkan backend. But it's not very far into development. Okay, let's find another model. And then we'll get to some lighting calculations. What's a good looking model? I need like... I don't know. What should I use? I want one that has like interesting materials. That would look neat. With lighting applied to it. Like maybe this medieval props low poly could work. I don't know. I don't know. I shouldn't think too hard about this. Maybe the silo low poly. This looks like it has a few interesting textures on it. Diffuse, normal, base color, specular. Exactly. Perfect. Free download. Let's get the silo in here. And while we wait... So I'm going to build a little level in Blender, basically, is what I'm going for. So we'll have a couple trees. Oops, I didn't mean to put that at the bottom. Let's have a couple trees. I don't know. Download that. How come this didn't come with a material file? They lied to me. Textures. All right, fine. This should work. Let me go back to here. Let me just add silo. And we need to get the model file. This thing doesn't have a material file for some reason. Oh my gosh. Why is this? Here, we'll just create the model file directly, I guess. Silo.obj. Paste. Did we get the full thing? I think so. Use MTL. Material silo. Sure. Yeah. Yeah, that'd be cool. That's the plan, at least. This model is probably a horrible test model, but it has like some normal maps that I can use. Let's just copy the material from the rat, I guess. Paste. Specular and norm. So in theory, if we import this, let's open another Blender instance. Oh, on the right side. So yeah, you're talking about this. So my build system caches. So I can explain this briefly. I've explained this a few times on different streams, but this stuff is like my build system. So when I click build, it runs this tool first, this build.executable. And that's what this text is from. So it does a bunch of stuff before it actually compiles my game executable. And primarily what that's doing is dealing with my game's assets. So if I go to like my game's output directory, we have my game executable here. So like I can click this and run it, right? But then next to this, I have this binary file. So this is all the game's assets, essentially, packed into a single binary file. So it takes all of the assets from like my game's asset directory or wherever I have these asset files. So like I have models here, like this rat.model is an asset type that points to an OBJ file and some textures. It basically processes all of those into the binary file. But then if I'm changing assets or adding new assets, it would be slow to do all of the work completely from fresh every time, right? Because like if I'm only changing, for instance, a shader, like let's run this. And then like let's change the shader for the shadows. Let's just like make this red. This is my classic example, right? The only asset that's changing here is this shader. So like you see only the shaders were dirty. So then it rebuilt the shaders, but it kept the objects and like all the other asset types. It just restored it from cache. So it was a faster build to do that versus do everything from scratch basically every time. So it's just like a way of speeding up my incremental builds. And the asset system has a way of tracking like asset dependencies as well, because multiple assets might depend on other assets. So like if one of the dependencies is dirty, then the whole asset is dirty. Like an example of that would be a sprite sheet where you have like one texture but contains multiple sprites. The whole texture becomes like dirty if any of the sprites change. So I'll like rebuild the whole texture with all the sprites in it. So there's like kind of a complex dependency. And the same is true for models, because a model can have multiple meshes and multiple textures or like multiple materials. Nuketown 3. Yeah. And I have a more verbose version of this that I can show in a second. Once I get this model in here, I'll demonstrate. So like here, let's just cd c dev manta project equals ga1 toolchain equals llvm clean equals 1. So this will build the game. Oops, I should have done verbose in here. Let's just demonstrate this even more, because I'm about to add the new model type. So we'll do verbose equals 1. So it's a more verbose output log. And it didn't clean for some reason. No, let me just change toolchain. Here, this will rebuild everything. And now this is printing a bunch of stuff for every asset type it's working on. So you can see like there are a lot of object files. This is like the game's entity system. There's all the shaders. And then here are all the asset types. So like we have all the levels, all of the textures, the models. And these were all dirty because it just rebuilt clean. Now if I go in and change, go in here and change a texture, like if I go to the rat and I like load up its texture in Paint, open with, where's open with? Open with, open with Paint. So if I like change its texture in Paint by just like scribbling all over it, let's just add yellow. Sure, the rat is now yellow. And I save that asset type, and now I just rebuild. We'll see that the asset thing was marked as dirty because it detected that one of the assets changed. But most of these textures didn't change, so it just grabbed these from the previous build. But it did see that this rat texture changed. So this one got built. And then, yeah, everything else got repacked, and then the binary was written with that changed asset. And then if I go to like the rat should now have, he doesn't have yellow on him. Interesting. Did I edit the wrong texture? Maybe I edited the wrong texture. Oh wait, no, the build failed. Was it because the game was running? Oh, the game was running, my bad. So it actually failed the build. It failed to launch because the previous instance was running. Yeah, here we go. Now the rat has the yellow lines on him. And if I change it back, so if I just like undo this and save and do the same little experiment, we'll see again that the texture changed, and now the rat has its original texture. So yeah, it's just the build system. Okay, so silo model. Let's get the silo in here. So if we import obj, C dev Manta projects, GA1 assets, silo.object. This thing is massive. Let's shrink this down. And let's get this guy not clipping through the ground. And the materials look correct, so that's nice. And we'll export this. Again, Z is up. Manta projects, GA1 assets. Silo, triangulate the mesh, save. Let's make sure it didn't break my material type. Looks good. And then let's just add this to the scene again as a test. Oops. Oops, I didn't add the model for this. What? Nice. Linux. All right, silo. Let's get this guy drawing. Again, it's just test stuff. We're gonna get to lighting soon. Should be fun. Yeah, here we go. Here's our silo. Looks pretty good. Looks good. This is the most exciting debug dev models. We have a silo. We were like ready for a first-person shooter already. All right. Let's make a little level in Blender here with this guy. So we'll import the silo. Projects, J1, assets. Silo is on its side, which is fun. Let's rotate that. Maybe the silo is bigger than the tree. I don't think it really has disadvantages, to be honest. I guess the one main drawback is that right now all asset types need to be built into the binary file. So like if I wanted to support modding as like an easy thing that the engine can do, so like if people want to write mods, they would have to like actually go in and edit my binary file format with their mods, which I guess is a drawback if you want to have mod support. But that's just such a low focus in my mind at the moment, so I'm not too worried about it. But it's certainly something to consider. Yeah. Oops. Let's just make sure the scene now loads in. Where are these texture paths? Yeah, this should work. Oh, unable to locate. Great. Yeah, because it sees it as absolute path. So I guess I just need to copy tree. I don't really want to delete that. Cache conflict. Crazy. I guess I don't need a model for these right now. So let's delete those. Cache conflict. What? How is that possible? Oh, it's duplicating the materials. Oh, that's so annoying. Why would it do that, Blender? Don't do that. Oh my gosh. This is why you don't use Blender, actually. Like, why would it make multiple copies of the material? It's exactly the same. Here we go. Yeah, I used to work as a game in AAA as a game dev, as like as an engine programmer / rendering programmer. I don't work in game development anymore. I have a different job now. But yeah, I was doing basically the similar stuff professionally for a few years. Okay, so the cool thing about this is I have access to the normal and the specular maps as well now. So I'm working towards just having the pipeline so I can start doing lighting. So let me see. In the model, let me add a little debug thing in the model, which lets me change which map I'm rendering with. Because right now I'm just using the color texture for my rendering, but let's add an option to like visualize what the specular and the normal maps look like. So static int model texture map is equal to 0. This will just be like just a flag I can change in the console, and then that will switch basically bind texture. So like right anywhere I hard code this texture thing, which is here. Let me make sure I'm not doing this other places. I am. So we'll have a static, or just say a const expert, I guess. Assets, material texture slot. Color. So we'll do color, normal, specular. These will be my 3 options. And then we'll just use this lookup table to branch on, or to decide which texture type to use. So now if I render this, yeah. So now if I use this, I can go texture map like 1. So this, oh, it didn't work. What? Why doesn't that work? Oh no. So the normal map didn't work because the specular map looks fine. Uh-oh. Am I not loading normal maps? Is that the problem? Interesting. Interesting. Am I not parsing them from the material file? That might be it. Build. Source. Build. Assets. Materials. Load from skins, actually. From MTL. Was I not parsing? I'm not parsing normal. Oh, I am parsing normal. It's probably pretty hard. The net code is probably the hardest part about it. Interesting, I'm not parsing normal maps. What did I do wrong? Scene. It's not even using the normal maps. Oh no. Okay, so I'll just add that in, I guess. I lost my normal maps. Silo normal.png. Tree leaves normal.png. Yeah, here we go. Here's our normal maps. So we can see the normal map. Looks pretty pretty basic. And then we have the specular map, which will determine our lighting equation. I don't know if this guy should be so speculary, but I'm assuming that's fine. All right, let's just add some lighting equations. I'm gonna need to do some, for normal mapping, I'm gonna need to do something with the model format because I don't have everything I need to actually apply normal maps yet. So I'll need to think about what to do with that. So we'll have one of these that's like lighting. Do I not use a logger? Not really sure what you mean by that. I just print to the terminal. So like I if you mean just like logging stuff as I need to. So I have like a bunch of functions. So like I have this function called print, and the print line is the one I use all the time. So I can like, you know, print some stuff. Here is a number, right? So this is like printf basically from C, right? So if I like run, this will just get spammed into the terminal over here on the right side, right? This I guess is my logger. I don't really do anything with it yet though, but this is a function that I have at the engine level now. So like if I want to intercept this function and spit it into a log file or do anything like that, it's trivial to just spit this into a file. Yeah, I don't know. I think some people spend way too much time thinking about logging and like random stuff like that when it's like kind of the least interesting part of doing game development. It's like it's trivial to add a logger. It takes like an hour or two to implement one into the engine. Like it's nice to have, obviously. It's nice to have a logger for debugging stuff, but I don't know. No, it wasn't the homemade Coca-Cola. Yeah. I've seen that video though. The guy who reverse engineered with like chemical analysis the recipe for Coca-Cola. Except he couldn't get cocoa leaves in the United States because it's like a class A drug or something. I don't use AI. No, I don't really like. All my code is written by hand by me. So no AI. Do you find you work faster without a game engine? I think I do, mostly because I understand the entire code base. But obviously it's not faster to make a game if you're making your own engine, because I spend so much time just making the engine. I don't actually spend enough time on the games. But I just do this for fun, so I'm just having fun programming. It looks like AI though. Well, it's not AI because you can watch the streams, you can see me programming. So yeah, there's that. It looks like AI because AI has to train on something, right? Yeah. It's hard to tell if people are trolling nowadays. Why not NeoVim? I don't know, because I just like VS Code. I'm a normie. Okay, so let's do some lighting calculation. I'll do the lighting after the shadows, I guess, because why not? maybe I should do lighting without shadows. I've been programming for like technically 18 years, but more accurately like 14 or 15. And I've been doing C++ for about 7 to 8 years of that time. So I started when I was a kid, but the first few years, obviously, I was like a kid. I didn't know what I was doing. But I actually started to like learn programming when I was, younger. Okay, so what am I doing? Let me think. So we need a light. We need like an uniform for lights. So I guess what is a light? We're just writing some very simple lighting here. So we have basically a list of points. We'll do float 4s because maybe the light will have an intensity. Doesn't change the fact I'm handsome. Yeah, okay. I don't know if that's true. So we have a bunch of lights. We'll just have one light for now. We'll have an array of lights, but it'll just be one deep. Because why not? And this is the light color, so the RGB color. And maybe the A is like the intensity. I don't know. I don't know what the lingo people use for this is. So how do we calculate lighting? Well, the easiest way to calculate lighting is to just do like a distance fall off between, the point light. So like we can have a float 4 light equals, it's like, I don't even know. What would you do? Length? It's not linear fall off. Here, let's look up the basic Phong, Blin Phong. Lighting model. Let's look at the what we use for this. Advanced OpenGL. Here we go. Here's a fun little thing. Oh, so we do need surface normals. I don't have normals hooked up yet. Damn, maybe I should get the normals hooked up. But look how easy this lighting is. You just like do this. My first programming language, actually, I used to use GameMaker, like the GameMaker engine. So they have their own little scripting language called GML. All right, let's do the. Yeah, this is the part I can do for the specular part. Or no, I don't want the spec part. Yeah, I can just do the things with... Oh, the light has a direction. The light direction is just the distance, the point to the light. The view direction. Yeah, let's just steal these. Is this the modern day vibe coding where you just go on to learn OpenGL and you steal the lighting code? See, the thing is, I'm not actually a very good shader writer. I don't spend time actually writing shaders very often, so I don't know all these fancy lighting equations off the top of my head. Frag position is just the in.position world.xyz. XYZ. The view position, oh, I need the I position as well, so we'll have like a float for, I guess I'll use float 3. Position I, so we'll need that. So it's like the camera position. Light direction plus view direction. I'm gonna say direction light. Change my variables here. So what do they do with these? baby. Yeah, I think that'd be a good first project. You should learn a lot about data structures and memory alignment and stuff through doing a project like that. And like that's half the battle is really just understanding intuitively how to deal stuff with memory and like, yeah, I guess all of that stuff. I should really just get my normal maps in because then I can do the actual equation for this. Because it seems like this example is only giving me normals. Because like, what would I do with this without that? I guess I can just do the... What do we use this for? Specular. I can stub this code in and then we'll have it. Well, I guess I do have the surface normal. I just don't have the normal map. So I can use normals. I don't know what I'm talking about. So we take the dot of the in.normal, because I do have normal vectors. For the models, I just don't have the actual normal map vector. Shininess, I guess, is the specular value, which I'll just do it to 1 for now, because I don't have that hooked up. Specular is equal to the in... Oh, I should have a light... So like light position. What was this? In dot light dot. We're still in the learn OpenGL code here. Why is that? Probably an exponent. Yeah, I should read the docs. What is shininess? When the shininess property is low, if you use a shininess exponent of 1 on a flat textured surface, because its specular reflections break down in certain conditions, especially when shininess property is low, resulting in large enough. Okay. Yeah, so you need like... Yeah. Specular exponent of 0.5. I'll play with it. Yeah, here we go. Here's an example of a higher... when did I start C++? About 7, 8 years ago. Okay, let's just see what this does. Let's just add this. Let's just print, let's just draw this. Let's just see what these values look like. And then, you know, if it doesn't look good, we'll change it. Is that correct? Let's populate this thing with values now. So where do I draw depth? So I actually want to have a separate render pass. So that's the shadow pass. So we want this pass. We need to use this shader. So like draw lit, draw scene light, lit, sure. And we'll use the new lighting shader. And we need to bind those uniforms. or upload data to those uniforms. So we'll just wing this for now. So we need a light position. I don't know where to put this. Let's just have like a static thing. Let's have a hotkey that will shuffle this, basically. If I press L, this will be my lighting value. It will just shuffle the light position. Equals camera.position, flip 4. And of course I need to actually render this little scene thing with this. This should be down here. And set the matrix. And set the depth texture for the shadows. All right, so what happened? Nothing really happened. Is it even using the texture? Model scene. Am I still rendering this? Render shadows. I expected to see at least something broken. So am I not printing that right here? Then maybe I need to clean. Yeah, I mean, I expected to see like no color at all for these models. I'm not really sure how this is working at all right now. What is happening? What'd I do? What'd I do wrong? Scene lit. Oh, I'm drawing the level twice. Okay, this should change it. Here we go. Here's our lighting. If I press L, we'll get like a different light. Yeah, it looks pretty wacky though. Like if I do it like here. Like, is it really the correct behavior that you see the light through the model? I don't think that's right. I mean, it looks fine to the side. But I don't think you should see the light through the model, right? Shouldn't the normal, like the dot product be making no light be emitted? Maybe it is that exponential, that specular, that shininess exponent. So I'll do 16 and we'll see what happens. Oh yeah, I guess it kind of does get hidden, doesn't it? So yeah, maybe that was what the problem was. But you still see some of it like shine through. I don't know if that's right or not. It's hard to tell, to be honest. Am I not doing that here though? Max? Where'd my music go? Interesting. Interesting. I'm normalizing these, so that's not the problem. What the hell is Objective-C++? I don't call back faces. What the hell is Objective-C++? Yeah, that's basically... So if you have no idea what... It's an Apple thing for Mac, basically. So here, I can run this on Mac and show you that. Because I was working on some Mac code earlier today. So I have support for Metal Graphics API, which is used on Mac. So this was like my little thing I was doing earlier today. And Metal is a Mac graphics API for like iPhone and their computers and all their different things, like the VR headset. And since it's an Apple-only API, they have written it in Objective-C, is the language that it's written in. So you can compile Objective-C inside a C++ project by using what's called Objective-C++, which is what these .mm files are. And basically the compilers on Mac implement a backend to compile Objective-C within a C++ project. So you can intermix Objective-C and C++. So that's how I'm calling Metal just natively through the Objective-C syntax stuff. Like you see all these crazy bracket syntax. That's like Objective-C, just grammar for their language. But I compile it in with my C++ code. So I have like C code, C++ code in here as well. Yeah, and they do have a C++ API. But all their API does is like wrap around Objective-C. So it's basically doing what I'm doing. They don't have a native C++ API. Their API is just a wrapper. But yeah, if you just want to use C++, just use the Objective-C, or just use the Metal CPP. Yeah, and it's weird because like Objective-C is actually, I don't know the exact history, but I'm pretty sure it came out, like they developed it before C++, or before C++ got popular at least. So Objective-C was like Apple's solution to creating an object-oriented version of C. And the way they implemented classes, the concept of classes, is different. And it's actually really, really inefficient actually, because they basically like, all of these things, like this blit thing is a function call, or no, this is a class. This is the blit class. And these are like functions, or these are class member variables basically. And some of these are functions. But the way this actually works is it's like, it does like a hash map lookup every time you like access a member function or like a member variable on a class, on an instance. It's like doing a runtime hash map lookup to figure out where the function is. So it's like really inefficient. It's pretty crazy if you like look into how it works. But yeah, that's what Objective-C is. Yep. All right, so let's see. Lighting. Lighting's fun. mean, it does work actually. I guess the exponent of 1 was like making it not work maybe. And this is like a really simple model, so there's no attenuation of the light. So like we would probably want attenuation as well. No, it's a real Mac. You know, believe it or not, I actually own a MacBook. I use a MacBook. I actually use the MacBook all the time because it's the only laptop I have. So that's why I have support for Metal and Mac at all. It's because I actually do use it. Here, let's get the scene also drawing with where am I? Let's add the actual scene level in here as well. So we'll delete this guy from here and add him in here. So that we'll get, this way we'll get the lighting on the scene too. So it should be a little easier to debug what's happening. All right, so if we plop the light down here. Yeah, so we're getting like the specular highlight component of the lighting. So this is like if the sun were shining, you know. What's the specular factor? Which actually looks right now. It's kind of disorienting with the bright sky. I assume we would want some like attenuation though on the light itself, because this is just a specular component. So we also want like the attenuation. So where's that? Did we not get that in this example? The lighting chapters cover. So specular. So we want the combined. So diffuse light, normal vectors. Da, 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 da. I already know this. Where are we going? Where are we doing attenuation though? Oh man, look at this crazy equation here. The reflectance equation. Oh no. Alright, so attenuation, calculate attenuation. We don't have any of this. PBR surface. Oh no, I don't want to do PBR yet. Yeah, this is when it starts to get complicated. Like now you have PBR materials. Yeah, let's get some inverse square law in here. All right. Yeah, so is that just the color, like the light dot light color? It's just the color divided by the length squared. Is that true? This is dumb to get length and then multiply it by length because length already does a square root, but let's just do this first. Yeah, because I guess it does fall off with the square of the distance because of the way that works. So this is what we need. Here, let's just get like... Oh yeah, that's a good tip. Yeah, I'll just do that. dot xx. Yeah, okay, so that's like this vector, right? Which I guess I already calculated up here, but I need that not normalized. What if this is a float 4? Oops, yeah, that's actually right. Let's see, how does this look? I guess this shouldn't be the max, right? That doesn't make any sense. Here, let's first just do the fall off. This should be like this attenuation times specular, I imagine, something like this. Because you want the specular to fall off too, don't you? I don't know. Here we go. We have... Alright, so we have some nice point lights here. Super weak, though. So how do we make this weaker is the next question. So like, could I just multiply this by value? Does that work? Well, it kind of works. If I want like a light that goes further, just multiply this. Is that intuition correct? Yeah, look at that. Well, not quite what I'm looking for. Looks cool though. That's actually pretty sweet. Yeah, look at that. That's some good thumbnail content right here. Not quite the effect I'm looking for though, because of this crazy intense color fall off there. Looks sweet though. I love that. All right, let me see the Learn OpenGL chapter on this. So you said it is in advanced lighting, gamma correction, attenuation. Gamma correction, attenuation. Here we go. So yeah, distance by distance, which makes sense. However, using this equation, the attenuation effect is usually way too strong. Yep, that's exactly what I'm witnessing. Giving a small radius that doesn't look physically right. For that reason, attenuation functions... Yeah, that makes sense. Yeah, I'm certainly not doing gamma correction. So that could be playing into it. So 1 over distance to the power of 2.2. Interesting. So let's try that. So let's see. Attenuation, vector light. So we'll do distance light is the length of this. Float. So let's try this. So pow this dot 2.2. How How does this look? Yeah, I mean, it looks a bit better. Less intense. Still kind of intense, but not as bad. And then we'll do our little trick where we just make it go further. I mean, you still get the harsh lighting. But yeah, with global illumination, you would have more bounce. So yeah, I guess that explains why you would want to use maybe not the quadratic fall off. You'd use the linear one. I guess the exponential fall off. Because if I did linear, just do distance, this will probably look better, but it just will be less realistic. Yeah, like look at this crazy stuff. So then what's the method? How do these combine? So we have attenuation, gamma. I'm not doing gamma either. Diffuse color is power of that times gamma. All right, without gamma correction. What's the point, mate? What's the point of anything? So how are these combined? Do I just multiply these? Like is specular multiplied by attenuation? Because I don't want the specular to vibe code. Yeah, let's try that. Let's do this like you recommended. POW. Final color. RGB. Float 3. Why isn't it like this? Oh, I need to do this. My shader language is quite verbose. So I need to set each thing. Oh, let's get the specular back on. Distance light times distance light. Yeah, this is my own shader language. Because I support multiple. Oh, this looks kind of cool. Wow, check that out. It's like looking at the sun. Wow. It really depends on the color, though, I guess, doesn't it? I guess like brighter colors are more intense with gamma correction. Is that how that works? Yeah, so my shader language. Yeah, so this, I'm writing in my own little shader language thing. And that's because I support multiple graphics APIs. So like I can switch to OpenGL and this, in theory, this shader should just work. We'll see. Maybe it won't work. I'm not sure why it wouldn't. Oh, what? What happened? Here, I have a separate bug going on here. Wait, what? What does this assert? I love when I do an example and then it doesn't work. No, I had tone mapping. Yeah, okay, let's see. Why did this fail? This should have worked fine. What is going on? Interesting. This was just working earlier. I was testing it. Which is failing here? Scene, render pass, begin. So the shadow pass, it doesn't like the shadow pass. Bind targets. And which one is it failing on? The color texture. Oh, I don't have a color texture attached. Here, let me just add. I know what the problem is. I'll fix this later. I just need to add. This is really dumb that I have to do this. I have this like non-graphics type. I'll just change this to a float for now. This should make it work now. All right. Yeah, here's OpenGL now, which is nice. And the lighting does not work. Oh no. Oh no. No, I did software engineering. Like computer science. All right, so let's multiply this. Okay, so I'm not a genius. I'm not a genius. Okay, so we have our... So how do we combine speculation with... yes, I know Tokyo Spliff. How do I combine the attenuation with the specular? Do I just add them, or do I have to multiply them? Like, what if I add them? What happens? Yeah, because like if I add them, I have my base specular, but then it like shoots out way too far. So we need the attenuation factor as well, basically. So I need to like do this, I guess. Maybe. But maybe you want less attenuation on the specular. Because you still want us to be able to see the specular highlights. And then do gamma correction. Yeah, so I'm doing gamma already. So I guess this has specular highlights. It's hard to see with some of these colors. Some of these colors. Yeah, because then we get... I mean, with the linear fall off, it doesn't look very great. So maybe you want a slightly more forgiving fall off. Like this doesn't look great. It is doing the fall off, but with linear, it doesn't look very good. So like, let's say we'll do like 0.01 here, and then we'll do 0.05. Yeah. Yeah, I guess I'm not extracting those from the files. I mean, that looks pretty good. You just, yeah, you would have to play with the weights, wouldn't you? Because like right now you can't really see the specular component. Yeah, see, like you can see it now because like you get this band towards the light. Yeah, I'll make it a different color. It's a good call out. So we'll just make this red. So yeah, then the red is like the specular highlight component of this. That's a good point. It's a good option as well. I mean, that's pretty cool actually, because you can see the kind of the specular bounce off things in the distance. I don't know how well this comes up on stream because it's probably getting killed by compression. But it's kind of neat. Yeah, I mean, I'm happy with this. This looks fine. Rat spinning. I do have a spinning rat. Yep, that's true. I need to figure out why this doesn't work on OpenGL now. I'm kind of concerned. Yeah, here's my spinning rat. So what happened to OpenGL? This should have worked. Because there's really nothing different. Okay, so we get the specular. We're just not getting the light color on OpenGL. So why is that? I guess that's telling me that the light color value isn't making it to the shader for some reason. So why would that be? Is it getting a value? Let's render doc. Oops. Let's render doc it and see what we're getting. This probably is the alignment. I was hoping that wasn't the case because I spent a lot of time on that that system. But let's see. So this, where we actually render this is this draw call. Let's just find a draw call where we render. Yeah, and then this uses, oops. Which uniform buffer? Oh man, it's gonna be impossible to find this. Where is the buffer? Element array, no. Because it might only bind it on the first draw call. Uniform buffer, here we go. 512 isn't right. Can I search these? No, I'm not a student. I'm older than I look, I guess. Man, this is annoying. It's because I have too many draw calls. It's like impossible to find what I'm looking for. RenderDoc does have a nice little thing where it like tells you what the data is when you like do the resource inspector, but is it in pipeline? Here, let's go to the draw call fragment shader. Here we go. Here it is. Uniform shadows, uniform lights. So we are getting. That's the wrong uniform buffer. Yeah, here we go. Light color 0, 0, 0, 0. Damn it. Why is that 0? So that's at byte offset 32, float 4, right? So is my padding wrong on my struct? Output, generated, shaders, GFX. Offset 32. This is in the correct spot. So we have the light color is being offset in the right spot. So why isn't that making it to the GPU? Interesting indeed. I don't know. I work in software engineering. I do graphics programming. I'm 27 as well. Yeah, this is a graphics debugger. It's called RenderDoc. So I can take a frame capture. So light color. Yeah, I am setting it to 0. Well, I set it to red here. Oh, light color 1. It should be 0. How is DirectX even working? I was setting this as 1. This should be 0. How did DirectX work? All right, that explains it. Here we go. Now we're working. I love that stuff. Thankfully, my graphics code gen wasn't messing up the alignment of my struct, so that's great to see. I mean, I'm not using any frameworks basically for the engine. So like it's common for game engines made in C++, like hobby ones, hobby game engines, to use frameworks like SDL or RayLib or like GLFW or GLAD, GLAD for like OpenGL context stuff, or GLM for matrices. I don't use the standard library from C++ either, mostly for compile speed reasons, because the C++ standard library just takes forever to compile. So like everything you see is written from scratch, but of course I'm still using libraries for graphics because I have to use I have to use OpenGL or DirectX or something if I want performant graphics. Like otherwise I have to write my own like software rasterizer or something and blit my own frame buffer. Because I like some of the features of the C++ language. So I like references instead of doing like a dereference of a pointer all over the place to edit, like mutate things, right? So I like pass by reference as a concept, even though it's syntax sugar over things you can do in C. I like namespaces. I like function overloading. I like templates sometimes. I don't really love templates, to be honest, but I like them for certain things. Yeah, that's why I use C++, pretty much. Yeah, I guess they aren't just syntax sugar, because there are some guarantees with references if you use them correctly. Like, references are nice because you know that they can't be null. Unless you've done something really dumb inside like a reference to a null pointer. Which you can do. It's just like if you do that, you're actually being stupid. So yeah, references are nice. Write my own driver. The diffuse part should probably be clamp. Okay, let me try that. I like this. This is some group programming here. So you're saying the diffuse part, which is this part? Wait, direction normal, direction light. So where is that? The diffuse part. Oh, you mean, so the non-specular part? Because this is like my diffuse lighting here is this attenuation factor. So I should do something with this too? That's what you're saying? Yeah, I guess I'm not counting the directionality of the surface either, aren't I? So like I need a diffuse, yeah, you're right. So I need a diffuse part of this. So so we have like specular. I guess attenuation should just be something part of diffuse maybe. Yeah, because I've kind of hard-coded in attenuation here. I'm certainly deviating from the gold standard. I'm a vibe shading right now. I'm not in school. I graduated school like over 5 years ago now, so I've been out of school for a while. Not super long. I'm not like super old, but all right. Let's think. Let's write. So we need a direction normal. So the normal vector. Okay, let me write this. So what'd you say? Clamp dot clamp diffuse equals clamp. So you wanted me to take the in.normal dotted by the direction light. So that's direction light. Okay, yeah, that makes sense. Yeah, so we do that. Clamp, and this should be what? Between 0 and... Is this between 0 and 1? Am I saturating this? So it should be like this. And this is like a scalar, right? Because I'll multiply this then. Here, let's just okay, look at the out color thing. Out color. I'll do color out just because I like to do it that way. So we have our power of, where's my light color? This one, lights.color times attenuation times, and attenuation should just be like the constant, right? Because it should be like, because it fall off would affect all colors through that. So like when I multiply by this, I basically do that division. Times diffuse plus specular to the power of 1 over 2.2. And then this becomes that. I'll just do RGB for now. So attenuation, diffuse, specular needs to become, what is happening here? I guess this is specular. This constant. This scalar is my specular factor. So let's try this. Oh, did I not do parentheses? Oh, yeah, you're right. And I got a compile error about something. Failed to compile shader. Vec4 float. Unable to find overloaded function. What? Do I really need these as a float 4 as well? That's crazy. Exponent. I really need to put this as its own thing, don't I? That's crazy. I need to make my shader language understand that if I just do this, it wants all the values to be the same, but I just haven't added that as a feature yet. So I have to do that. Oh my gosh. Factor. Okay, let's see. All right, this is looking good. Yeah, look at this. Looks great. There we go. Looks awesome. Ooh, yeah, I'll click that link. Give me a second. Someone asked, if I'm not using CMAKE, are you just using G++? Yeah. Yeah, it's a good question. I can answer that briefly. People who are frequent to the stream probably getting getting annoyed by my constant explanation. Oh, I'm using the raw normal. Is that true? Yeah. I think my normals are normalized already from the model, but maybe I should normalize it. But anyway, I can explain the build system. So yeah, I don't use CMAKE. I have my own build system. And it's basically just a batch script and like a shell script on POSIX if I'm on Mac or Linux that I can just kick off through writing to it. So I can like do boot.bat, so bootstrap, give it to my project. So this will kick off a compile of the game. So here we go, the game compiled. And as you can see, by default, when I'm on Windows, this thing used MSVC. So like it had to load in the MSVC vars up at the top, which is kind of annoying. But it uses MSVC. But I support Clang and G++ as well. So I can set the tool chain. So if I use LLVM, it'll use Clang. Yeah, I really should create a frequently asked. So yeah, this compiled with Clang. And you can see that here it's calling Clang++. And then I can do GNU for G++ as well. So use the GCC tool chain. But yeah, the way this batch script works essentially is it runs this build tool, which does a bunch of asset processing. But I ultimately generate my own Ninja files, which Ninja is the one that actually kicks off the compilation and the linking. So if I go to like the output folder, you'll see this build.ninja here. So I generate this Ninja file and I give it like a compile rule and a link rule. And this is what calls the compiler with all my compiler flags, and then the linker with all my linker flags, and then my whole project. But I generate this Ninja file myself depending on the project. So I can like easily jump between projects just by changing, you know, which project it's compiling for. So this is like one of my other games. And I was using CMAKE originally when I started the engine, but I just moved away from it because I realized it wasn't necessary. Because I was doing a lot of things that CMAKE was already doing. So I was like, why don't I just simplify my build pipeline by removing the CMAKE dependency? If I already have a system that's like globbing my, yeah, the water physics are nice in this game. This is my Terraria clone project that I always use as my little example. So this project's a little more serious than my first-person shooter thing. We have Terraria at home. But yeah, so I just removed CMAKE because my build tool already was doing a lot of like globbing of files in my project, and I'm like, it's kind of trivial at that point to also glob my source files, and just create a Ninja file without CMAKE. So that simplified my pipeline. Okay, so let's see. Back to lighting. It's my own physics. All right, so let's actually multiply this now. So I assume the final lighting color is this multiplied by the base texture, or is it added to the base texture? That's the other big question. I assume multiplied, right? Normalize in.normal. It is normalized already. I can show you where that's being actually generated. because I get my normals straight from the model. So in the model loading code, I have this vertex normal thing down here. Normal X. Now maybe it's not normalized. Maybe it's a good call out. Yeah, I'll normalize it. Why not? It's easy. And that will make sure that we are normalized. They should be normalized, but maybe they're not. So in.normal. Where do I use that? In.normal. Let's just do a float. Is this a float 3? Yeah. Was it producing artifacts? Oh, that's a good call out. Yeah, you're right, isn't it? Yeah, because it would interpolate linearly. Yeah, that makes sense. So yeah, I was being naive with my... Oh, that looks cool. Look at that. Yeah, because if they interpolate it like around a shape, right, it's going to linearly interpolate the 3 components. And then that wouldn't be normalized anymore. It's not doing like a rotation, right? It's doing just a linear... See, that's something I would just have never thought about. And I would see like a lighting problem. I'd be like, why is this not working? All right, cool. So now I want to combine this with my diffuse color. So how do I do that? So like I have my in texture. Is this just, do I multiply them or do I add? Because I think you want some of the light to like bleed through, don't you? Because if you just multiply, then it'll look muddy, I guess. Like if we just do this, I don't think this looks correct. But maybe I'm wrong. I'll just have to see. I guess I would multiply it, not here. I would do it at this stage probably, right? Like you multiply by diffuse times your color. And then the specular is a highlight that gets added on top, I guess is how that would work. Yeah, diffuse color times diffuse light times specular color. Yeah, because you have... Yeah, that makes sense. So ambient color plus diffuse color. Someone's revving their engine outside. I don't know if you can hear that. Yeah, then we solved this problem with the lighting being visible in the other direction. That's cool. All right, let's... Looks like SWAT 4. Okay, let's do this. So out color is light color. Would you say light color? So diffuse color is my... Yeah, I want gamma to be the last thing. So yeah, exactly. So maybe I should gamma... Here, I'll do like a float for color gamma, and then I'll have like a color just RGBA. So this is like my just non-corrected RGBA colors, and then this will be what I do the power on, just so it's like obvious to me that this is the last step. And I'll just copy this over here, and then this would just be that, right? Are the scenarios you design in just code, or can you show what you're based on? You talking like the scene, like the level? Yeah, so I was just making these in Blender. So like here was just like the silo and the trees. It's just a Blender model file. And then I'm just loading these model files in just through the code, basically. All right, so let me think. Yeah, it's just a forward rendering shader. Because I will want to probably do a deferred renderer maybe as an optimization of this later on. Or like a forward plus renderer would be cool. Yeah, so this should bring us back to... I'll just do the whole gamma thing here. Doesn't really make sense to multiply alpha though, so I'm just going to send this as RGB. So then gamma is the last step. So yeah, then we'd have some like base diffuse lighting. So we have, here, let's just comment this, shininess. So we have our diffuse, specular diffuse attenuation. So maybe we'll order these in terms of their... to when they come into play here. So we have our diffuse factor, our specular factor, and our attenuation. I guess attenuation's first. I'm just ordering my thoughts here. Yeah, I'm not a Blender expert either, by any means. I'm just using it as a means to an end. Okay, so we want... What was the equation you said? I should look at the link, maybe. So ambient light plus diffuse color times diffuse light. So diffuse, so this would be like my color texture times my light color plus specular color. Or wait, no, this is the wrong diffuse. So this factor is what gets expanded, right? It's like you're doing this. Specular color times specular light. So I guess your specular color would be your light color, right? Let's make this obvious. So it's like this. And then this would just be your diffuse texture color. Right, so it's like your color texture times your light color. And then I guess we can multiply all of this by attenuation at the very end, because then that kind of makes more sense. So something like this maybe. Light has just one color. Yeah, you're probably right, aren't you? So is it... So it's like this? Yeah, that would need some intensity factor, but I'm not going to add that in yet. It's hard to tell because I don't have the normal maps hooked up. But like, that doesn't look right. You know? I guess I have like shininess, so it's treating my diffuse as like a shiny texture, so maybe that is fine. Grab gold from the material table. Yeah, let me grab that link you sent. Let me pull that up. Gold. Yeah, so here's gold. Let's do this. So we'll just have a float for, which is like color light. All right, yeah. Diffuse light. Or I'll go material diffuse. I'll steal these values. I'm not really sure what an ambient material is. Isn't that just like the ambient light color? Unless that is a material. Alright. So let's plug these in. Shininess is this now. Light color. No, my eyes are fine. Alright, where's the actual equation for this? Because I feel like I don't have this equation right anymore. Yeah, that makes sense. So my equation is now what? Let's take a step back here. So our equation is, let me pull it up. Let me see what you wrote. So it was what? Ambient light. It was material ambient plus. Where's the link? Was it in the link? Introducing some materials. Yeah, this is like the classic fixed function GL lighting equation. That's fun. Okay, thanks for this. This is really helpful. Material diffuse times light diffuse intensity. So what is that? The diffuse intensity, where does that come from? Is that just a constant? So like this would just be 1 for now. Plus specular. Oh, is that my diffuse, this thing, times diffuse? Yeah, that makes sense. Okay, I understand. Yeah, times the specular intensity. Yeah, I got it. And then all of this, so this, is this just this term? So like, because then I need to multiply all of this by attenuation, right? Like I was doing before. Otherwise it won't attenuate. Don't forget about photons. Yeah, that would be helpful. Okay, yeah, that makes sense. Yeah, so you have a diffuse. So is material diffuse? This would just be like my source texture then, right? Like this material diffuse would instead be my, I guess I call it texture in my engine. But this would become like your color texture. Right, and then my specular would have to be my specular texture, and then the ambience, the ambient light value. Yeah. Yeah, I guess like if you know, do the foil, right? You just, I guess I could just attenuate these now. So then I don't need that extra term. All right, that makes sense. That's actually surprisingly simple. Uh-oh, what happened? Wait, how is that any different? Oh, it's because of this addition here. So ambient also needs... Wait, no, that's just my ambient light is super bright, isn't it? So like if I make this dark. Yeah, yeah. I guess your ambient would also need to multiply by the color texture, would it not? Any words in Spanish? I don't know Spanish. Hola. No hablo español. Yeah. Because the ambient is confusing. I mean, you probably do want some ambient term, but yeah. All right, I'm happy with this. I think this looks good. We can get the specular texture working now as well. Okay, so now that I understand, so I'll call this, instead of color texture, call this color diffuse, I guess. And then we also would sample our specular texture, so we have our color specular. Or I guess maybe this would be like my... These aren't really colors, I guess, it's like a specular map. So we'll have a specular texture as well that will sample. So then we can just replace that. Or I'll call these like map, because it's like a color map. Map, diffuse, map, specular, or material. I guess that's just, I just call it material. I'm already using material. I'll remove the ambient term. I'll remove this. Shine. Okay. And then we just need a specular. Did I spell specular right? Look at the normal texture in here as well right away. The discard is not necessary. This is like shadow code, which is kind of... Yeah, I worked on this yesterday. This stuff is pretty gross because I'm doing a for loop. Well, the discard is necessary for the logic I have here, but this, I need to replace how I'm selecting which shadow level to sample from, because I shouldn't be like just looping over all of them. I should be able to derive the level based on probably the texel distance or something, and then save a branch or save a loop. Okay, so we have this, and now let's just hook up the materials. So in the model rendering code, models, where we are binding textures, bind, oops, up here. We just need to bind, oops. I'm gonna go in color normal specular. So I'll probably do a PBR pipeline later, because specular lighting isn't actually physically accurate. I'm gonna remove this stuff. And then in the scene where I render shadows, we we need to set this to be 1, 2, 3. I'm gonna flip these. And set that there. Oh yeah, yeah. Morning, morning. So now in theory, this is sampling from the Specular texture. I mean, I don't really know how it's supposed to look unless I had like a very glossy material, which I don't have actually. So we're not, I mean, we get some specular on this because it's a shiny metallic object. I lost my light color as well. I need to put that back in here. Nice. All right, so we need to get, so should these be multiplied? So we have the diffuse material, but we also need to get the light color back in here, right? So in.light, because we lost the light color. So, I mean, I think I could just multiply this at the end. But I'm going to set it for both terms right now. I'm not doing Vulkan right now. No. The Vulkan is verbose. Yeah, I don't have normal mapping in yet. That's the next one. No, I don't always stream at this hour. Today's actually kind of an exception. I'm usually busy on Mondays because I usually have work at this time, but I have off of work today because it's a federal holiday in the US. So I don't have to work today, which is nice. Yeah, look, that looks good on the top there. Look at that. Okay, so now we need to do normal mapping. Normal mapping's a pain because we need the bitangents or whatever they're called, binormals. And I'm not calculating those yet for the model, so I need to calculate those probably because we need to construct our what's that matrix called? It's like an NBT matrix or something. Normal bitangent tangent matrix. Otherwise, our normal map won't map properly onto the, yeah, look at this. Look at these shiny bushes. Otherwise, our normal maps won't normal maps. Yeah, tangent by tangent normal. TBN, that's the one I'm looking for. What'd I say? NBT. Yeah, it'll take time. I don't think anything I'm doing is like super crazy. So, I don't know, don't be afraid to just do stuff. Yeah, I'm gonna add multiple light sources now as well. So we're gonna do a little for loop. I made the little map I'm flying around in. Let's add multiple materials. So it's just a for loop basically. Color RGBA starts out as 0'd. So what can stay the same? Point I, this can be outside the loop. This is outside the loop. This is outside the loop. Direction light, direction view. Yeah, everything else has to be in here. So it's all in the loop. And then I assume I just add the colors, right? So it's like plus equals. So let's have a little for loop. We'll have, I don't know, 8 lights for now. So everywhere where I was hard coding 0, we just set to I. Normal mapping. Yeah, that'll be the next project. TBN matrix. That should be fun. I'm just gonna add multiple lights because it looks fun. I guess I can get the shadows back on as well. So let's add 8 lights in here. And then the scene, we'll just have a little pool of lights. We'll 0 initialize this guy. This is when you go to a deferred renderer, because this starts to get really inefficient. There we go. Now we have multiple light sources. They all look pretty crazy. Yeah, deferred is so inefficient. The hand model reminds you of Counter-Strike. Yeah, I think some of the models are from Counter-Strike. I don't remember where they all came from. I've just had these just as like models in some of my project files for a long time. Is there another country I'd like to visit? I don't know. You have almost nothing. Yeah. Yeah, I've focused most of my engine stuff on basically everything except actual graphics features. So here I am like stumbling through Blinn Phong lighting. But I have everything else. Well, not everything. Peru, maybe. I would love to visit Peru. I want to see Machu Picchu. Yeah, my frame rate's probably tanking now. All right, let's get the shadows back in as well. That should be fun. So RGB. So we'll just do our lighting equation here, and I'll steal this from the shadow map. Yeah, I had this like shadow thing. So this is the shadow factors like this. Oh, I already had this up here. Let's move this down. I don't know if the gamma is going to throw this off, but we'll see what it looks like. Yes, now my shadows have the weird gamma going on, so I'll need to have gamma corrected. Well, not gamma corrected, but yeah, this looks crazy. Here, let's turn off the gamma term. Let's just do... I just want to see what it looks like without gamma going on. Yeah, I need to gamma correct my materials, and I'm not doing any of that. It's like without gamma, what does the lighting look like? Yeah, it looks pretty bad here, doesn't it? Look at this. Yeah, I'm making a game while making the engine. Yeah, so yeah, basically that's what I'm doing. So this project I'm working on, this is mostly because I want to add more just YOLO. Oh, I should do that. Yeah, that could work. Yeah, but yeah, this game is just a project. I basically, I want to flush out the 3D capabilities of the engine. So, and I want to do some of the net code. And I haven't really done the net code yet on the streams. But this little first-person shooter project is meant to basically force me to add graphics features that I'm not using in my other projects as a way of keeping the engine moving forward in its capabilities. Because it's easier to like add features as I actually need them versus like trying to, you know, just blindly think about, oh, what features do I need in the engine, and then just kind of adding them. So yeah, that's why I'm working on this game. So like this isn't really a game I'm going to actually pursue beyond the prototype stage, which is why I'm like being kind of lazy with how I'm developing it. But I have other games in the engine too that I'm taking a bit more seriously. Here, let's gamma correct my materials. And let's see what this does. Wait, am I supposed to inverse gamma correct them? This looks worse. Just YOLO. Where'd that message go? Yeah. So I want to do the... Yeah, you want to do the inverse, right? You want to I was going to say, this doesn't look right. Ah, this looks better. Look at this. Sick. Lighting still looks like really muddy though. I don't know how to describe it. I guess it's because I don't actually have a material yet for the ground. It's just like sampling really ugly materials. Sorry, I'm reading the chat. Can I grow a beard? No, I don't have good genetics for growing facial hair, unfortunately. I look better clean shaven. Yeah, our shadow maps, what was the question? Our shadow maps and texture? Yeah, so the shadow maps are procedural, so they are a texture. So if I go into... Here, let me switch to DirectX, because it runs faster. I don't know why this frame is taking so long to load. What's happening? I can show it. So, like, one of these passes, I generate shadow maps. This pass. Well, this wasn't a very good capture. Let me grab a different capture. Yeah, exactly. Yeah, so I basically render into textures from the sun position. So like if I go stand here, I actually have a debug. I don't know if it still works. Yeah, I disabled my debug on accident. But if I take a graphics capture like sitting here, I have these render passes for shadows on the left. So here's like the depth buffer that gets generated. So this is the first cascade level. So this is like the closest one, the highest resolution one. And then they slowly step further and further back, basically. So I have 4 cascade levels. Kind of unnecessary because you can see the 4th one. The 3rd one's fully encompassing the map, so I don't really need 4. But I have 4 right now. And then I just sample those. So I can make the sun move around if I want to make things a bit more dynamic. So we can do something like this. Oops, let me close render doc. This should make the sun move around in theory. Yeah, here we go. So you can see they're moving with the sun angle. PCSS. I'm not familiar with the acronym. I do want to make my shadows look better though, because they're kind of pixelated. Like you can see the pixels in the shadows. And maybe I should make my shadows darker. Let me make them darker. Because now I'm using like gamma correction, so everything. And yeah, this is why they're so expensive. Because yeah, you're basically rendering the scene multiple times. You basically render the scene multiple times. Now you're doing a depth only. You're doing a depth only render pass. So at least you're not really paying for the full rasterizer if you're doing depth only. So it is a bit more efficient than just doing a full raster of the scene. Yeah, what classes helped? I don't want to be too mean to university. He's having anything PSO star yet. I don't want to be too mean to university, but I didn't really learn any of this stuff from college. This is all like self-taught. College was good for learning like the fundamentals of computer science. So I learned a lot of like the theoretical stuff and more formalized. Like I think some of the most important classes in my mind were like the ones on discrete math and like algorithms and like proving algorithms, right? So kind of understanding formal proofs. Like that was insightful because that's not something that I would have learned just learning, like teaching myself, because you just never have to do that. So it's just like there are no classes on this that you could like realistically expect to take. Let me get the tint thing back in here. Oh, I was editing the wrong one. This should be 7.5. I had a little tint factor that I was adding to my color. This is so I can visualize the cascades. I want that visual back, that tint. I had a little cascade visualizer thing going on here. All right, and then let me make sure I set this. Yeah, here we go. Here's my cascade visualizer. So you can see which level each shadow map is sampling. How long did it take to build a game with your engine? Oh, yeah, sorry. I was ghosting the question on the red underline errors. So I use ClangD, it's called. ClangD. Let me go to the extensions. This one, ClangD. This one's really good. But unfortunately, it actually is kind of a pain to set this up because in order for ClangD to work, it's basically running the Clang like compiler front end, I believe, over your code base. So it reads from this compile commands JSON file, which is basically just like compile, like it compile commands for LLVM. You have to like maintain this file for all of your source files that you want IntelliSense for, ClangD for. So my plugin that I have, my plugin thing at the bottom, it generates this file for me automatically. So like if I add new source files or change them or anything, are you actually a fellow Badger? Well, which UW? Because there's two. There's Wisconsin, and then there's also Washington, and it's always confusing. Wisconsin is definitely number one, though. That's funny. Small world. Oh no, what happened? Failed to initialize the server. Oh, I'm running the game. That's what happened. But yeah, so I had this cascade split thing going on. Yeah, Madison. So this is cool. Let me turn that off though. The good one. What are the odds? I have like 90 viewers in here. We've got some Madison, some Badgers in here. That's crazy. Badgers represent. Yeah, look at this crazy shimmer. That looks horrible. You can see the cascade split here, where it goes from high quality to low quality. Okay, what should I do next? I don't even know. What should I do next? I guess I should get the normal maps working. That's the next step. So I need my TBN matrix. So we're gonna have to get the, we're gonna have to calculate our bitangents. Unfortunately. TBN. So yeah, because I think, isn't there a way you can get the bitangents using the texture coordinates as like a cheat? Maybe I'll do that first. Yeah, baked shadows would be cool too. Those are actually easy. Not as hard as you'd think. I've implemented those before. Ambient occlusion. Implement the cat. So many questions, so many options. Well, I thought there's like two ways to do your TBN. There's the one way is you can get, because you need you have your normal typically from, like that's kind of a given, is you have a normal in your vertex format. And normal, you either have the bitangent as another field in your vertex format, right? So like in this lighting shader, I would need to either have a float 3 for my bitangent, right? Or my binormal, I don't even know which one it's called. And then from that, you can use the cross product to get your, I guess, your tangent. Here, let me find, I think someone sent the link on this. Oh yeah, tangent. So like you'd have your tangent as this. And this is what I was gonna do because it's easy. Well, it's not easy, but it's like not crazy hard. Yeah, and then you can just calculate your assuming these are like orthogonal to each other, you can calculate your binormal, your bitangent. This man knows ball. Oh yeah, Washington, the best one. Yeah, see, I'm in Wisconsin. We're competitors. Okay, because I know you can also calculate the tangent vector by using, I think there's a cheat where you can use the UV derivatives. So you basically just use your texture map derivatives to calculate your tangent, and then you can use that to then calculate your bitangent. Let me see. Tangent vector from UV. I think I vaguely remember this was a thing you could do. Are 3D vectors aligned with the surface of the mesh that point in the direction of increasing U or V texture coordinates? Commonly used for normal mapping. Yeah. They're computed as unit length vectors, perpendicular to the surface normal, often requiring calculation based on vertex positions, mesh triangle, da 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 da. Yeah, I think I'm better off just calculating them when I load the model and then passing them in as vertex data. So I'm going to do that. Because that would be easier. Okay, let's see. So it's gonna get mad at me, so I need to copy this to the other shader. Let's make sure I have all of these accounted for. Well, maybe I should do a specific variant. Oh, I don't know. Let's think. Let's think for a second. Vertex forward. Okay. It's just like I've done projects for many years. Okay, this is gonna be bad. I've done projects for many years. GA1. Not. Sorry, let me just fix this quickly. Well, I'm missing the tangent in one of these here, this one. Okay. This should break everything, I believe. Okay, yep, expected. When you say self-taught, what do you mean exactly? Material? Yeah, so I've done projects of just various things, and like I've just learned through the projects. So like I have some goal in mind, and it's like I just have to learn how to get there. And then over time, you just accumulate all this random knowledge on things. And of course, I'm still learning. Like right now, I'm doing random lighting calculations. like I don't know this stuff off the top of my head. I know the theory behind it, but it's like I don't know. I don't know lighting equations. So like this is an example of an instance where I'm just learning this stuff, and I'm thinking through the problem. Because I actually don't write shader code that much. I'm more of like I guess a systems level type programming when it comes to graphics. And hey everyone, welcome. I'm seeing some familiar names in here. Yeah, I can explain floating points really briefly. So essentially a floating point is just a value with a decimal. So like you have like some number equals like, if you have like 1.5, right? So you have this F on the end. This is saying it's a float basically in C++, C++ syntax. But a floating point, what does floating point mean? So floating point is talking about the decimal point, can float around in the value, right? So like you can have 10.5, you can have, you know, 10.0005, right? So the decimal point floats around. If you're familiar with scientific notation for like large numbers, you know, when you have like the format like 1.5 times 10 to the x, you know, this is scientific notation. Floating point is very similar to that. In fact, it's like essentially the same thing, where you can represent numbers with decimal points using a float. An integer isn't like that. So like an int number is only whole numbers. So yeah, maybe float toy. It's a good example. So integers are only whole numbers. And the thing is, an integer is very simple in terms of its memory representation. So like in binary, the number 1 is just like, if you have an 8-bit binary number, right? You have 8 zeros and a 1. So this is a 1, right? This would be like an unsigned int, I guess. So like if you did a unsigned integer, so you don't have to worry about the signed bit. And like 2 is like binary this. 3 would be this. 3 in floating point is not represented this way. So yeah. So yeah, and then in C you have the float type. So this is 4 bytes large. So if you like do a const size int size float. So like if I get the size of this is 4 bytes large, which is 32 bits, typically 32 bits. You have different precisions, so you also have a double. So a double has 8 bytes. So what that means in practical sense is that you can represent a number with higher decimal precision, basically. Yeah, I can show you. I did some work on this just now. Well, I actually just broke it. Here, give me a second. Let me just plumb some stuff through my build tool very quickly. And then I can show you. I was about to add tangents and bitangents. So I need to fix this. I just need to shut up this compiler error. Damn, this isn't gonna be that easy, is it? That should have been fine. What was it mad about? Size of vertex format is equal to 0. Here, let me just revert the change I just made, so I can show you. the current state, and then we'll dive into the bitangent calculation, and we'll fix this. Here we go. Yeah, so this is how far I got with shadows. The shadows look nice now. Well, they look as good as can be for basic shadows. And then I also just added some lighting, which doesn't look too well in this scene with the shadows turned on. But I was just working on some basic blend Fong. It looks pretty bad, actually. The specular component looks pretty bad right now. But yeah, it's just some basic lighting stuff going on. Do I have book recommendations for beginner level? I don't really have book recommendations, unfortunately. Maybe someone in chat has some good ideas for books. I didn't really learn from books for programming, so I don't really have any good examples to refer you to. Oh yeah, and I can debug the cascade level, just as like a fun little thing, so you can see where the cascades are in the level, where the splits occur. So that's fun. Always nice to have debug code. But yeah, okay, so we're gonna add the bitangent. Yeah, I have shadows from the sun currently. And yes, I'm mostly self-taught. What language? C++. Smooth class. I have book recommendations. Yes, I think Learn OpenGL is a great resource. I was just on there earlier here. Okay, so let's revert this to this. The tangents back in. Sorry, I'm just thinking. All right, so build a tool. This should break again. So actually, I'd need a padding value on here, I think. Because I think it was throwing off the padding, maybe. That's what was happening. Okay, so what's the size? Something's off here. $48 bytes. So, and it's mad about what exactly? Is this a different size? 40. So somehow that is 40 and the other's 48. Position normal tangent. How is it packing these, I guess is the question. So 12 plus 12 plus 12 plus 4. So it is tightly packing them. That's interesting. I thought there would be padding on the floats, but I guess not, because it can see through that. Okay. How long have I been doing this for? What font? I'm using Iosevka font. Sorry, I want to start from the top and work my way down. Do I work in the gaming industry? I don't currently, but I did for a few years. So I worked at a AAA for about 3 years. But I don't work there anymore. I switched jobs about 1.5 years ago, 2 years ago. And I was doing rendering stuff at the job. So maybe I don't need padding. I thought that was the problem, but I guess not. So that's 40. So this should match perfectly. Let me just clean this and rebuild. No, I never did fix that. Okay, this does work now. I said to rebuild from cache. Okay. Cool. So now my vertex format has a tangent value. So now we have to calculate the tangent value. So I guess, how should we calculate that? Yeah, so I did make this model for this scene here. I didn't make like every individual model, but I made all the houses and stuff. But this is a level I made like years ago for an old project of mine. Like I think I literally have on my YouTube channel. You can see that some of this stuff, how do I go to my channel? Like here we go. I have a video of this map from 12 years ago. So I'm using old assets from my old games. So this is a game I made like 12 years ago on the same map. So I'm just reusing old assets for this project because I'm more focused on the engine stuff right now, not the game. And I have like some other debug stuff rendering over here in the corner. But yeah, the glass actually does not render at all now. Did I miss a question? If I missed a question, you can just re-ask it. Is cool seeing VS Code in C++? I like the custom build says. Why Clang over GCC? Yeah, so I do have GCC. I'm just using Clang right now. So I can use GCC as well. I support all the compilers. And then, am I using CMAKE? No, I'm not. I'm not using CMAKE. I guess I technically use Ninja. But I like have my own build pipeline that generates the Ninja file that ultimately kicks off compilation. Okay, so we need to calculate bitangents. So how to calculate tangent from for mesh. I don't like this AI, but it's actually convenient. So do you just use like calculate tangent? This creates 3D tangent space. Iterate through triangles for each triangle in the mesh. Calculate the edges and the corresponding UV deltas. This sounds like a pain in the ass. I don't want to do this. Yeah, I can explain that. I've explained this many times before, so some people are probably over it. So I have my own build tool. I'll go through this really quickly, just to not bore people. But essentially, my build system, I just have a batch script. I have a batch script and a shell script for POSIX that can just take in the project name and like maybe the tool chain. So it's like, say I want to use GCC. I can pass in GNU as my tool chain, which is the linker. Oops. I'm in the build. Let me step out. I'm in the wrong folder. So if I just run this, it will kick off a compile with GCC. Okay, yeah, I can skip the big monologue. Yeah, no, I don't use it with CMAKE because ultimately I realized my build tool was already doing what CMAKE was going to do for me. In that, so like, what would I use CMAKE for? I would use CMAKE for basically dealing with kicking off the compiler and the linker, right? So like, what is the compiler? What does that actually need? You need the compiler, you need the source files, and you need a bunch of compiler flags. And maybe the include directories is like commands to the compiler. And then the linker obviously has linker flags. And CMAKE is basically a higher level way of dealing with all of that stuff, right? So you don't really have to deal with the compiler directly, which is fair. But I realized through the build tool I was doing for the asset system, where I was already like globbing over my project workspace, that I was already doing basically everything CMAKE was doing for me, minus just generating the compiler commands. So I was like, if I can already glob all these asset types, it's trivial to just glob my CPP files and figure out what the include directory should be for those, and pass them. And then instead of using CMAKE, I can just, from my build tool, directly generate this Ninja file. And CMAKE uses Ninja under the hood as one of its, like, it's optional, but it uses Ninja to actually do the compilation. So CMAKE generates you one of these. So rather than using CMAKE, I just generate this myself. And then I just run this directly. So I don't have this extra CMAKE layer that's like getting in the way. And that's not how I originally set the engine up. So I was using CMAKE in the beginning, and I found it annoying to have to deal with CMAKE plus some of like this other dependency stuff. So yeah, I just didn't. I eventually just removed CMAKE as a requirement. So now I just build without it. And I support all the compilers because I just have different compile rules in this Ninja file that just like, okay, use GCC or use Clang or use MSVC, and it just works. So that's really nice. Yeah, I maybe I should go full custom. The nice thing about Ninja is Ninja deals with caching the compilation. So like, and maybe I should just go full thing, but like Ninja deals with caching, like if you change a source file, it will only rebuild that source file rather than a full recompile. So Ninja has its own cache system for the actual code. Yeah, and I have considered Unity builds. My builds are already very fast though. So like, here, let's go to a simpler project where it's not doing a bunch of asset loading at startup. And let's do D3D. So like here is a globe project. And if I just run this, so this was a full compile of this project, fresh, including the build tool that was like dealing with assets. So it built this executable, which had 41 source files, and then it ran it, and then it built this one, which has 55, and the whole thing took 1.8 seconds. Now, if I don't build the build tool and I just recompile the game, it's just really fast to do a full recompile with my code base. So like Unity builds wouldn't really save me too much, but it's definitely an option. Okay, so anyway, bitangents. Speaking of tangents, how do we calculate these? This is really annoying. Yeah, and the plugin. So that's related to the build tool I have. So this is a custom plugin for my engine. Okay, tangents. I don't know how to calculate these. I thought you just take like the edges and then you calculate them from that. Bump mapping in OpenGL shaders is usually done through tangent space, which has the normal tangent by normal. So orientally connection is actually fairly complicated. Yeah, that's not what I want to hear. First time seeing me Google something. I'm Googling stuff all the time. I don't know this stuff off the top of my head, unfortunately. Okay, so here we go. Calculate tangent array. So we have a triangle, which is an index buffer. So what do they do? So they go over each triangle, and then they calculate the texture coordinates and the UV, and the position and the texture coordinates. And then what is sdir and tdir? Oh, these are variables? What is this? Okay, so yeah, that could make sense. Maybe they explain it. So like the top part here, we're just calculating like edges, right? So we're taking like the vertices and subtracting them. So we're getting like edge directions, I believe, for like 2 edges of the triangle. And then this is like the delta texture coordinate for the triangle. And then R is what? 1 over, so it's like an inverse of... Is this like normalizing it or something? Like we want these normalized. And then tangent. So we calculate 2 tangents. And then what do we do with the 2 tangents? So we take tangent. Where's tangent 1 used? It's not. It's only used in one spot. Or no. Obviously not. Okay, so NT. So we do need 2 tangents, because then from those we calculate the actual thing. Yeah, the good old assembly. Okay, we're gonna do a little shameless copy and paste. Your CMAKE build takes 30 seconds. See, I couldn't live with that. 30 seconds is too much. Where I used to work, the builds would actually take significantly longer though. So, oh, interesting that this is oh, 2 times vertex count. So he just made 1 malloc call. Okay, I see what he's doing. All right. Here, sure. Let's just copy this shamelessly. So we need to calculate our tangents. Calculate let's just shamelessly steal this guy's code. But we need to adapt it to our code. So we'll loop over all of the vertices. This is annoying because the vertices are indexed. So I need to undo the indexing. Have some dignity. So I have an index buffer. So I actually need to iterate over these through the index buffer, I guess. So where is that? Indices. So we need to iterate over this guy, which is unfortunate. How's that going to work? Because tangents don't work with index buffers, do they? Because, like, what happens if 2 triangles use the same vertex? Yeah, yeah, that's a similar story to where I used to work. Is the builds would take, if you did a clean build of the entire game, it would be like at least half an hour. And incremental builds were equally, well, not equally slow. Yeah, it was like similar to what you're saying. And we had Threadripper CPUs as well, and 256 gigs of RAM, which was it's just impressive how long it can take. Okay, so I'm confused. How do tangents work with vertex or index buffers? Because like, what if 2 triangles what if 2 triangles share the same vertex? It's like I can't have. Do I have to split the vertex buffer, or do I have to interpolate my tangent, or do I have to like blend my tangent into the I don't know. I don't know what to do. I guess we'll just write the code and see what happens. We'll see if it looks good or not. Okay, so we got to get the... Let's just grab the vertex. Starbound. All right, let's see. What are we doing here? So I. So So this should be plus equals 3 because there's 3 indices per face. So I guess we need position and UV. So this is our position. What is the type of this? Vertex position equals what? And then this is the texture coordinate. We don't need this. Texture coordinates dot u v v v v. I don't know what's happening here. Okay, we need another. We need another list. We need another type as well. So we have a vertex tangent. We have 3 lists of tangents because why not? So tan1 so each index adds this to it. I guess that makes sense. And at the end we normalize. Yeah, sorry, I can run the game in a second. I can show you. But I'm trying to get some work done. If otherwise I'm rendering, or otherwise, oh, this is sorry, what am I thinking? Otherwise I'm not getting work done, but I'm just so confused what this syntax is. Vector 3D. Okay, so we'll add the tangent things. So we'll have a T0 for every index. Yeah, get these tangents generated. I'm just confused in the order of operations here, because this is, I think I see what's happening here, and the way I'm doing this won't work. Because I should be looping over the triangles first. And then from the triangles, I need to cache the indices. So like I need a concept of a face. So it's like I need to loop over the faces. And then for each index in the face, I need to accumulate the tangent vector. And then at the end of that, I like normalize it. And then I get like a tangent vector where if 2 triangles are adjacent to each other, sharing the same vertex, the tangent will be like the correct value, assuming that gets interpolated, I believe is how that works. This is just for simplicity. So in my build, this is my build tool we're looking at. So I'm really lazy with memory management here because this doesn't matter. This is just like a one-shot build all my assets. The game runtime is more efficient with how it does memory allocation. Like I'm not just haphazardly throwing lists around that like malloc in the runtime. But this is at build time, so I'm like processing the model data. Then I'm generating tangent vectors. I just need to think about this for a second. Sorry. Okay, so how do I generate triangles? So I need like a pass. I need a pass that. Here, let's add some types. Let's add some types like GFX struct a triangle will contain like index I0, I1, I2. Here, we'll just make these ints. We're just making some basic types. And then we have, I guess these can be uSizes, even though I don't think I'll ever have more than that. So our first pass is to just triangulate our mesh. So we'll loop over the indices. And generate a list of triangles. So we have a static list of triangles. I'm sure there's a more efficient way to do this. I'm just doing this first because we have to triangulate why is this so confusing to me? Maybe I'm just confusing myself. I can't map this part of the code correctly without doing this. Bear with me. I need to think. So from the index buffer, we can reconstruct the triangles. Like doing this is as easy as like adding, like would be add, you know, we add a triangle, which is, you know, I plus 1, I plus 2, right? But that doesn't actually save me anything, so I'm confused why I'm doing this. Is indices a map? Maybe I should loop over the map of faces. Where do I use faces? Maybe this is what I'm looking for. I'm gonna worry about this later. I'm just gonna see what happens if I keep doing what I'm doing, and then we'll like actually look at what the triangles, what the vectors look like, the tangent vectors look like from this, and then we'll just see what happens. Because I0 is just this, so like if we have we need a list of these things. Yeah, so, okay, so this should be like tangents 0. I guess I'll call this tangent 1. So Esther is a vec3, so this needs to be doing something too. Oh, okay, so this is a vector 3. So we're just constructing a vector here. That's what's happening. So it's like... so that's just expanding to this. I don't think this is going to work, though. So like this is like this guy. And then the tdir is this guy. So this adds 3 tangents. So like this can be indexed by the index buffer. All right, so now we have like a list of tangent vector things. And then the last step is when we actually go to write the triangles, the vertices, we loop over. Yeah, I guess this is the problem now, because now we don't know. This music's really loud. There's a matrix inverse. Yeah, I don't know. I assume these were, I assumed we were normalizing vectors here, because this is like a 1 over, so this is like a length, I think. But also that doesn't make sense, because we're like subtracting here, so maybe not. I don't know. What music? You guys not hear the music? Where's Soding when you need him? He was in the chat a few weeks ago, or a few days ago. Like a week or 2 ago he was in here, which is funny. The legend himself was watching for a bit. Okay. So let me look back at the secret sauce over here. So when we go over the vertices, so T is normal tangent 1. So what do we use tangent 2 for? Calculate handedness. So we use the second tangent for the handedness. So we basically need this stuff. So when I calculate, we can calculate this up here, I guess. So we'll have to like calculate our tangent. I guess this doesn't need to be const. Well, it could be const. It doesn't matter. We can make this const. Why not? Do I not use my math types in here? Why am I not using my math types for this? This is actually kind of stupid. Because then I can do these things easily. And a tangent's technically a float 4, isn't it? So I wasn't using these as float 4s. That's annoying. It's annoying. Okay. Because the tangent has a handedness to it. We'll just do float 3. Float 3. Float 3. Let's skip this stupid custom type thing. Alright, so we get the float 3. from tangents. The problem is that this is based on triangle count vertices, which are different. Normal index. Where do I generate these? This isn't even fundamentally complicated. It's just hard to reason about what my data types are. So like, what am I actually iterating over? So am I iterating over each vertex, I guess, right? Like, but I can't do that because then I don't know who the neighbors are. Right, so I need to iterate over these. Indices.add index. Okay, let me just copy this stuff first and foremost. So the tangent is, I'm not using, like, what is A? I don't know how to do this. It's so confusing. So triangles and then vertices. That's the annoying thing. So triangle count is obviously the faces. Vertex count is the individual vertices in the buffer. I wish my math intuition was better. I'm a bit flaky on the math stuff. Gotta be honest. I don't know why I'm wearing a coat. It's getting hot in here. Here, I might step away for a second. I need to use the bathroom. I'll get the game running so people can actually see what's happening, though. And then we'll come back and work this out. Oh, wrong game. Yeah, can you send the link again? I think you just sent it. Oh, you just sent it. I'll grab it in a second. Oh no, now what? Here, let me fix the compilation first. Just undo all this crazy stuff. Here, we'll get the game running. People can look at it and watch the pretty shadows. I'm gonna step away for just a second, so I'll be right back. All right, I'm back. I made myself a peanut butter sandwich too. So I might mute while I eat because I don't want to be making munching sounds. So I'll be muted for a second. Okay, I'm done. I'm back for real now. Yeah, this makes sense to me. And this definitely makes sense with the code I was writing. I guess the part I'm getting confused about with my code is that I have an index buffer as part of my... So the problem is I have an index buffer. So, like in this code, and I guess the code I was writing, the assumption is that I could just loop over the vertices and then, you know, loop over the triangles, I guess, and then get the 3 vertices. And then the tangent for each... Is this the tangent for the triangle then, I guess? You calculate the tangent for the triangle. And then each vertex would get this tangent. Which makes sense to me. Where's the music? But with a vertex buffer, the problem, or with an index buffer, the problem is that triangles can be shared between multiple faces, right? So you can have like 3 faces that share one triangle. So I guess in the other code I was referencing, they did this accumulation thing, right? So like instead of just setting it here, they accumulate these values for each, I guess, triangle, or for each vertex. And then at the end, they loop through all the vertices, and then they normalize them. Which I guess would kind of average them out. So I guess I just need to do that. So that makes sense to me. I'm going to use this one. Well, I'll use both. I'll kind of reference both because I think both do what I want. I just need to kind of combine them. Because with the index buffer, Yeah, I was just running the game. So this is what I'm working on like right now. I'm working on this little retro styled FPS shooter thing, and I'm working on the lighting. So I added the shadows yesterday. I just added specular lighting, so little point lights. They look pretty bad right now because I don't have normal maps. So now I'm getting normal mapping working, which means I need to calculate some tangent vectors. But yeah, this is what I'm working on currently. And yeah, the whole engine's from scratch. And if you want to look at like any of the actual code, I have the GitHub public in the description. So the whole source for the engine is up there if you want to take a look, if you're interested in that. And there's some other projects I have in the engine too. Like, I guess for anyone who just joined, I have this Terraria clone, which is a more serious project I'm working on. I haven't worked on this too much the last couple weeks. I should really get back to this. But this is like a 2D game with some cool water physics and some kind of nice cloud background rendering stuff going on. So this is another game I'm working on. Quite a bit of time actually. How much time you spend? Yes. I don't know. In moderation. I program a lot though because I work my job as well. Normally I'd be doing like my actual job at this time, but I have off of work today, so I'm streaming instead. I don't know how much longer I'm going to stream though. I might stop streaming at some point today because there's some other stuff I want to do later. And yes, it does run on Linux. And I can... Oops. I just cut. Hopefully I didn't just ruin the stream there. Yeah, I can show Linux. I just used my switcher. So it runs on Mac too, actually. So here it is on Mac. Here's a little game I was working on. Let me switch to Linux. I can show all of these before I get back to my... So here, I'm just remote desktoping into my Linux computer. So I'm on Debian right now. But the engine does work on Linux. I don't know why it's taking so long to load. This is a pretty slow computer, so it takes a while. But here it is on Linux, which is kind of cool. So yeah, it's cross-platform as well. So let me exit out of this. And let's calculate our tangents. Okay, let me think for a second. So what I want to do actually is, so I want to loop over the vertex. So I have this vertex tuple. So I actually need to add the tangent into this as well. Probably. So this is what I was missing in my other... It's not a tuple anymore though, but I guess whatever. Yeah, thanks. Should I take a look? Run engine Linux. I'm on Windows right now. I was doing some Mac stuff earlier in the stream though. Okay, so where do I create these vertices? So everywhere I add a vertice, I guess I just need to add an index for the tangents. So in here, this is where I need to add the tangent to the tuple. So where do I have positions? Oops. This is kind of gross that I'm doing this, but this is how it's going to be for now. So we'll just add an empty tangent because we'll calculate these later. So we set that, and then we add the tuple. Fine, that should work fine. Or I guess we can do this, so we don't have to -1 this. Sure, you link your engine. It's up to you, I think. There's pros and cons each way. Normal faces. Yeah, there's pros and cons for each way, basically. Okay, so now we want to, when we loop over these, we actually want to find the vertex tuples. So right, and then the positions is like P0. So where I was, let me just change these before I do anything stupid. P0, P1, P2, W0, W1, W2. So these come from this. All this code to like decipher an index buffer. Yeah, dynamic linking. Yeah, it's cool for. What's your approach for the engine? How do you link it? So my engine just compiles into the game. So like I compile both. So I don't do any static or dynamic linking for the engine. It's like the engine's just compiled into the runtime. And the reason I have it set up that way is just that I haven't put in effort to make it like an actual library yet. Because maybe in the future I'll want it to be like a static, the engine module will be a static library that gets linked at like compile time, right? Link time. But I'm not doing that yet. Just because I didn't do it yet. Okay, so then we also have, so here when we accumulate these, it's like tangents at the v0 dot tangent index plus equals ester. And I guess I need 2 of these. So like this is the tangent 0. Or S tangent? I don't even know what you call this. I'll call this S tangent index. t tangent index plus equals v1, v2, v1, v2. What do you mean by manually handling matrix transforms? I'm going to wrap this in a type just so it's easier to reason about this list. So a vertex tangents, these are very confusing because I have two names that do the same thing, but this is like my W tangent. Or my S tangent. And I don't even know where these names come from. I'm just stealing it from the other guy's code. So we have two of those. And we pass that around. So tangent index remains the same. You know what, let's expand these. Doing these on a single line is kind of dumb. For readability's sake. Okay, so I actually don't need this at all. So now when I accumulate these, I can just use dot so then I can do that, and that will add that guy. And then down here, finally, I can do this normalization stuff. So we get the const vertex tangents equals tangents. Where is this? Why is that mad about that? I'm not sure why this is upset about this. Const vertex tangent does not provide a subscript. What is that talking about? Is that just a fake error? Yeah, you can post. I don't care. That's fine. Yeah, that's part of rasterization. So I know the title says no libraries, but I'm using like graphics APIs to render. So I'm obviously using hardware rasterization. So yeah, I need to construct and pass those matrices for the transformations. Okay, I don't know what's going on here. I'm just going to assume that something dumb is happening. Unless I'm like shadowing the word tangents, but I don't think I am. Because this is a list of those. I think it's just a fake error. So T tangent is equal to, well, I guess we don't need that. So T, let me uncomment this. So it's this tangent minus see, I should really be using the built-in types for this. I'm not sure why I'm not, because then I have to do dumb stuff like this. So we'll clean this up in a little bit, but let's just get this working. We normalize that. Total dot product of normal, v normal times tangent. All right, and then, so this is our tangent is this. Then our handedness so it's our normal minus dot cross our product, and then this is tan 2. So this should be our S tangent, I think. Right? Maybe I messed that up. So T is tangent 1, so yeah, this should be our S tangent. And then times our... Why they call this T, but this is actually... okay. S tangent, S tangent. S tangent times tangents dot T tangent. And this is a crazy line. Where am I from? I'm from the United States. I went off on a tangent. It's true. Oh, my keyboard. I have a Ducky keyboard. I think it's the 1S model or 1.2. I don't remember the exact model name, but it's a Ducky keyboard is the brand. And this should be T tangent. All right. I think that's finally it. I think I've done it. So now if I pass, well, let's just first see if our tangent is correct. So we have our tangent.x, tangent.y, tangent.z. Just vibe code it. Okay, so I have an error. Let's see, what's the problem? What do you mean, tangents doesn't have... Am I shadowing tangents? What is this? What is going on? Let's delete this. We have to clear this, otherwise we'll be in for a sad day. So we cleared that. I guess we have to clear this per thing here, right? Or maybe not. No, I don't think we have to. This is per mesh, per model, we'd calculate those. I don't know what this error is. Am I being dumb? It's always possible. Did you disable IntelliSense? Keyboard. Show feet. S fine. Why are you using that instead of concepts? Where are you seeing that question? Where are you seeing the concepts? Are you referencing a specific part of my code base? Because I think I do use that somewhere. I don't remember where. In the serialization, maybe? Something like that. I have some crazy thing for the serializer and the buffer. Yeah, I don't have a good answer for that. I was, yeah, you're talking about like the buffer write and read thing. How I can like custom override functions for like read and write. Also, the serializer has that. Yeah, I was just kind of, I really didn't know how to solve that problem. So I think that was like the first solution I saw that actually did what I wanted it to do. I'm not really familiar with C++ concepts actually. So maybe that is a better thing. I don't know. I don't have a good answer. Yeah, I know what you're talking about though. Yeah, because like basically whatever I did there allows me to have like a custom static like void like write function. So like I have a class, you know, like I have some like struct some class. And if I give this thing a static void write function that takes in I think like a buffer and some other stuff, it'll detect whether this class actually has it when I go to like use it, like when I'm writing to the buffer. And that was like a mechanism that allowed me to do that. But maybe concepts is better because that's actually like formally supported with templates, right? It's like a template thing. Maybe I'll revisit that. Okay, I'm being dumb here. Tangents equals tangents. Obviously, it's not going to work. Tangent. Oh, this is annoying. ST tangents. Tangents ST. Sure. It's been a while since I wrote that buffer code, so it's kind of it's lost to me. Some of that template craziness that I was doing, I understand it in the moment, and then it's gone. Poof. Okay, so we didn't. Well, let's do a full clean build. We didn't immediately crash. Damn it, we did crash. List at 74594 is out of bounds. 74594. Where would that happen? I can't easily debug my build tool, which is where this stuff comes painfully. It becomes a pain because I pass like random arguments to my build tool to get it to run. So hooking the debugger is annoying. So where could this be failing? At what point is this failing, I guess? I don't even get a call stack. Does one of these give me a workable call stack? Here we go. We have a workable call stack. Load from OBJ, which actually is not very helpful. All right, so we know we're erroring in here somewhere. So do we get to the bottom of this ever? We're gonna do some print debugging, unless this turns out to be a waste of my time. Interesting. Actually, I could keep this consistent with this if I do this. It's like we have an off by 1 or something. How do I manage to get those colored buttons? So it's a custom VS Code plugin. How long have I been coding? I just use malloc right now. No library does not mean no OpenGL. I explained that in the description. Yeah, I am planning to hide the seams. Yeah, I need to get to that at some point. I'm not using... Oh, you're right. Well, no, this is correct, I think. Or no, you're right. Because the index should be... should be this. What I recommend learning. So I think the most fundamental concept you should learn is memory alignment and like cache lines. Like if you just learn about what cache lines are and how memory layout affects cache, that's like pretty much the biggest thing you kind of want to worry about when you pick an algorithm, because on modern hardware, operations are really fast. Like actually doing, you know, operations like add, subtract, multiply, those are really fast in terms of clock cycles. The slowest part is fetching memory, right? So when you write an algorithm, generally you want to prioritize how quickly can memory get into the registers for the CPU to actually start doing stuff with it. So most of the optimized like algorithms out there are designed to like minimize the amount of memory fetching, right? Minimize the amount of cache misses. What's the other question? No, I've made engines in the past. This is just like an evolution of things I've worked on over the years. Sorry if I missed the question. The mini MI malloc. Yeah, that could be interesting. I don't do too much memory allocation at runtime, so it's not really a big deal. I kind of like allocate in big pools, and then I just at runtime I just dish out memory from the pools. So kind of like an arena, except I don't reset the pool. So it's just like, I don't know, memory pool allocation is what I fall back to for most things. And I just allocate all the memory at startup or whenever, at like critical points in the game. And then, yeah, that's how I do it. So runtime, the memory isn't too bad. In the build tool, I'm being a bit lazy though. So this is like build tool code right now. So this only runs once when it's like working through the asset files. Okay, I need to think for a second. What's happening? So indices, what are in indices? So indices add, if a face contains an index add faces vertices that add tuple. So how do I sample this? This is with the index, right? So if I loop over vertices, interesting. This is really complicated because of this index buffer stuff. It's like I need to undo the index buffer in order to calculate these tangents, but then I need to also like map them back to the indexed vertices. So it's like this extra layer of convolution over like what I'm trying to be doing here. So are these 1-to-1? Let me just assert this first. Size, oops, this is not the right spot. These should be exactly the same, I think. But maybe this is what's messing it up. Because I think I might be resetting one but not the other, maybe. So we'll see if this assert fires. That assert does not fire. Okay, so these are the same. So I should be safe to just use I here because these shouldn't map to anything other than... I guess I should be using vertices, I suppose. The thing is the vertices... I know the indices are in order. Well, actually... Oh my gosh, this is so confusing. Here, I'm going to change this from being... faces. What is a face? I'm using the git extension. In the keyboard, it's a ducky. Let me just look it up. People like this question. I should put this in the frequently asked questions. Ducky, keyboard, 1, 2. I think it's this one. I have the full size one though. So wherever this is, it's like one of these, except I don't have RGB because I don't really care about RGB too much. It's this one. Mine wasn't $200 though. This was like $100 when I bought mine. So I don't know what's going on here. This one maybe. I have the cherry reds, I think. The reds switches. Okay, sorry, I'm reading the chat here on the side. I haven't even gotten to the normal mapping yet. Yeah, that's exactly what I'm thinking. So, like, I'm looping over 3 of them. And then for each iteration, I'm just adding an index. Right? Indices.add. I add the index. So there will always be the same number. For every face, I have 3 indices. That's how this works. So I should be safe to... here, I should be safe to just do this. I equals their I-list index account. So these are my vertice tuples, right? Because I added 3 of them. Back here, you know, we add 1, 2. Otherwise, we index one that already existed. And I guess that's where I'm messing up, because these should contain the value from here. So yeah, I should be reading. So I was doing that wrong. That makes sense. Because indices can duplicate. So this is actually that. So that's our true index into the vertex tuples. And then we get the position and the text record from those. And then tangents. Should add, and then I don't know how many hours I have on C++. I don't keep track of that kind of stuff. Yeah, this isn't out of bounds, but this is just like a fake error. Well, it's not a fake error. It is indexing out of bounds. I know that. I don't think it's an off by 1 though. This is just my error message. And then, let's see. I should really just hop in a debugger and figure out where this is going wrong. You know what? I'm going to let the seg fault catcher figure this out, and then I'm going to run with the address sanitizer so I can see precisely in the call stack where this is actually killing me. So, because right now I have these operator at, and then this is the error that's actually firing. It's firing here. So if I get rid of this, it should just seg fault now because I'm trying to index memory that doesn't exist. I don't know why that's taking so long. Well, it didn't seg fault because it's actually fine, but now if I go into the build tool and I just make this thing use the address sanitizer, this should seg fault. Oh my gosh. Oh, it didn't hit the seg fault? What? I'm so confused. I'm genuinely confused right now. That definitely should have faulted. Or the address sanitizer should have caught that. That's concerning. That's very concerning, actually. Let me just make sure this is working now as a sanity test. Let me just force. Oops. Unless address sanitizer isn't working, which is also possible. Which it looks like that's the case. Oh, here we go. So it does address sanitize. Yeah, so it does give me the stack. So it caught that. It's just not catching. Oh, this is so annoying. I spent like an hour on this. That's suspicious. Very suspicious. Well, I know this isn't wrong, so maybe it's because I'm malloking. Yeah, it's not segfaulting because I'm not indexing out of the allocated block, but this is an invalid state for my system because current is like the current insertion point. What do you mean, why did I not template? It's because I don't want to pay the cost of template instantiation on every source file that includes my math library, because that like actually significantly nukes your compile times if you're doing that. And like, I know I will only ever have a double and a floating point type. So it's like, why would I bother with templates? Templates are like, you should really avoid templates unless you actually need them, is kind of my philosophy. Because otherwise it's like your code kind of balloons into this meta, like this generated explosion of complexity at compile time. So I just wrote those. And I know you can do explicit template instantiation. Yeah, but I explicitly instantiate those. So it's only expanded in one file. Okay, actually I can answer this. So I template, yeah, and I honestly really shouldn't template the vector libraries because this actually does have an impact. So I can explain this. So if you look at the template stuff, core. So if we look at like, what does matrix do? No, I did not use AI to build this. So like some of these things do sine and cosine, right? I use trig functions for some of this stuff. And there's like constants in here. So if you mix float and doubles, you basically have like implicit casting to like the highest precision type, right? Like if this is float, but then I use the double version of square root, it's going to implicitly cast that to a double and then back to a float, right? So you're going to pay the cost of converting between float and double all the time. Whereas there are built-in float and double variations of these functions. Now, arguably the compiler will be smart enough to see that and select the correct one, but that's not an assumption I want to make. Like, I don't want to rely on assuming that the compiler is smart enough to understand that I don't want implicit casting between my floating point and double types. So like I have specific versions that use the floating point, tangent, sine, cosine. There's like a few of these. And then like the floating point uses the floating point version. Now I'm not doing that for vector because, I don't know, I guess I was lazy, I suppose. But I would certainly consider doing that. All right, so I'm kind of getting over this bitangent stuff. Okay, yeah, you have standard square root, but then like you include standard library and your compile times go in the trash. So it's like pick your battle. Okay, I'm just like twiddling my thumbs. I should really hook up a debugger to this. How did that work now as well? I didn't change anything and now it's not complaining at me. Oh, here it is. Oh, look, I actually have decent output now. Oh, I can see where it's trying to with the address sanitizer, I can actually see where it's trying to do this. Okay, so here it is. v2.tangent index. So it made it to v1, but v2 has the wrong tangent index. So that's interesting. It's arguably not a little bit less compile time. It's like actually a lot of compile time because your math library is something you include all over the place. And it's also code that you never touch after you write it, so it doesn't have to be templated. Like you can just write the code and then never have to worry about it again. So I don't know. It's like, are you lazy or are you not lazy? And this is the thing. It's just like these kind of debates are some of the least interesting debates in programming. Because it's like, it's so easy to change the code. If I ever want to template it, I can just go in and template it. Like I have both versions, I can just convert it to a template. Like, it's just so uninteresting to me that people debate this. It literally doesn't matter. What matters is what you're doing with this stuff. You know, like what does your program do with the tools that you provide? So like if we're gonna have debates about semantics, it's just like not very interesting. I can quit smoking at any time. Yeah, listen to me cope. Yeah, exactly. Thank you, Akim, for saying that. Like, these little things add up. So if you're not careful, like... And I've actually compiled this. Yes, I have done this. See, there's a nice tool you can use. Let me see where it is. In my downloads folder, you can actually see the time it takes to compile stuff. We'll do this as a little experiment. So, 1 second. Give me a moment here. Let me copy this thing over to my games directory. I'm on the other screen. So there's this tool called ClangBuildAnalyzer, right? And let me look up the documentation because I forget exactly what I have to call this thing. ClangBuildAnalyzer. Right. Here we go. Let's just see how to call this thing. Anyway, I have a project. This one, if I go to LLVM, and let's just make sure I have the compile flags set correctly for this. Yeah, so I want to be in release build just to debug this. Okay, so this is a little test project. So there's a compiler flag you can pass to LLVM called ftime tracing. So this will generate little JSON files next to your object files. And this contains time tracing stuff. So if I call reveal in file explorer, output, Manta, CMD, command prompt. Let's see, what does this say? So to use this little tool, we can use, alternatively, so you can do this. I can paste this in. Artifacts folder is output runtime, and then this will be capture. No JSON files. What? Here, let me pass the full path. All right, and then how do we view this thing? 1 second, let me find this. And then to view it, we can do analyze. So let's copy this command. Oh my gosh. Okay, so here we go. Here is the breakdown of compile times for my project. And this gives me some information about, what took the longest. So my most expensive header file in my project is the GFX header file, which takes a total of 424 milliseconds. It's included 19 times, average 22 milliseconds, right? Math is up here. It takes 11 milliseconds right now, include 24 times. So I spend a quarter of a second, and this is the full times here over all the threads combined. So the actual time is less than this, but this is the accumulated total time across all threads. So you can just look at this, and based on this, you can see, you know, what are your most expensive header files. And I already optimized, I went through this experiment and I optimized the compile times for my math library already, which is why it's only 11 milliseconds. And then you can see, okay, which are the most expensive templates to instantiate? Where is it? There's something in here that says that, unless it's not showing for some reason. Files that took the longest, expensive headers. Okay, it's not showing it for some reason. Why is it not showing the full text? But yeah, anyway, this is a good tool. So if you want to like play around with this and do some experiments on your own, I guess, the tool is called ClangBuildAnalyzer. And you can see exactly how long it takes to compile. But anyway, back to tangents. To end my tangent. But yeah, I prioritize fast compile times because I like just quick iteration. So that's why I'm passionate about this. I used to work at a company that was very, let's just say, careless with compile times. And it took like 30 minutes to do a full clean build. And it's like, I decided when I was doing this engine that I'm never going to let it get to that point. So I'm being smart about how I do things. Yeah. Very active. Yeah. Based take. I agree with that. Like, I think interesting debates. I mean, I don't know. Like, I find, you know, I guess, I don't know, maybe it's just personal opinion. I'm not, like, making some grand declaration. It's just what I care about, I suppose. But, like, I would be more interested in discussing things about, like, you know, what algorithms are you using? Like, an entity component system, you know, versus, you know, a mega struct for entities. Or, like, if you're doing shaders, like, doing an Uber shader versus, like, precompiled shader variants or something. Like, that stuff is more interesting because it actually has implications on the architecture of your code and, like, how your engine works fundamentally. Templating versus not templating a math library just doesn't really seem that interesting because it's like, okay, yes, I could template it and use the C++ feature. Or I don't. But I don't touch my math code that often, so it's, like, not a big deal, you know? What does it save me in my actual game, you know? It doesn't really save me anything. And in fact, it makes my compile times worse. So I'm actually losing something, you know? All right, so I finally got an error message on this because I turned on debug stuff. So I actually had debug symbols so I could see the correct call stack. So it was failing here, which means that this last vertex is off. So, like, if I remove this one, that's just an experiment. Will it go through? I mean, arguably, it's not correctness either. Like, what is incorrect about writing specialized functions versus a templated function? You know, it's like, then I'm just assuming that I'm going to mess up as a programmer. And, like, if there's bugs, then it's just my fault, right? I don't think it's a correctness problem. Yeah, I'm using those up here though, so I don't think that's the problem. All right, so I'm still getting an error, but now it's somewhere else. So now it's up here. Is it still? Man, this is so annoying. Yeah, I will load my asset types at compile time too. So while my I don't know if you're memeing or not, but that would not work because this isn't a compile time thing. It doesn't know what my assets are when I'm compiling my build tool. It's like my build tool is an executable that can be compiled once and then ran for any project. So I can't compile time parse my assets. That doesn't make any sense. What I really need is to be able to attach a debugger and not waste my time doing print debugging. See, now that's a debate worth having. And I'm kind of being an idiot by not doing this. You could expression tablets that fancy math libs do increase runtime performance. Yeah. Okay, I have a fundamental misunderstanding. Let me just let me just simplify this. Let's just see if I can expand to the correct indices first. We'll rely on this. So we'll just do one vertex at a time even, because then we can simplify the problem. Because I must be making a bad assumption here. Printf debugging. All right, so interesting. So we error here. So this is not correct. So it gets a vertex, but then the vertex doesn't have an accurate position index. So what do I use position index for? Maybe I'm just misremembering my code. Am I supposed to subtract by 1? Of course I am. Why would I not have baked in the subtract by 1 into the index? Yeah, that would be a perfectly reasonable, logical thing to do, wouldn't it? All right, we're in. That took forever because I have the address sanitizer running. So the only reason I have a -1 here is because I'm loading straight from an object file, like an OBJ file, which is 1 indexed instead of 0 indexed. So I had that -1. Oh my god, that's so dumb. All right, fine. You know, I'm fine. I'm fine with opinionated takes. You know, I'm not mad. I kind of like the combat, you know? So if you have an opinionated take, it's like, feel free to share it, you know? I like the passion. I just disagree, but it's fine. It's not like the end of the world. All right, so that works now. Well, I don't know if it works, but I think it works. Do I need the -1 on these now too, though? So we'll see if these error. Okay, so that didn't error. What a waste of money. All right, so I think I need to subtract 1 on these as well. Because why wouldn't I? I don't believe in the memory safety debate. I think that's a stupid debate. That's why I do it. If you want a hot take, that's my hot take. I think memory safety is one of the stupidest things people always parrot around. It's like, oh my god, memory safety, memory safety. You know the easiest way to have memory safety is you just allocate a pool of memory and then you just dish from that. Like, then your memory issues are off by 1 errors or something. Like, okay, you don't want a malloc all the time, then just create an arena and then just dish out memory from that. And then, like, I don't know, it's just easy to not be memory unsafe. I don't know why people always debate this. Okay, I think I have tangents now. Wow, that took forever. All right, let's debug. Let's do some debugging, some fun debug code for these models, just to make sure our tangents work. Because I don't even know if these are correct. Don't save. We'll have a cube, the default cube, and then we'll export this guy. Or maybe we should have a more complicated model. Let's have insert, add mesh. Let's do the icosphere. And then we'll export this guy as an OBJ. C dev Manta projects, assets, new folder, sphere. Let's start easy. How do you modify the build command in ClangD? Are you talking about the compile commands JSON file? I like. I mean, but calling Rust not memory safe is a crazy statement to me. I mean, like, yeah, I don't know. I don't really want to get in this memory safety debate. Otherwise, I'll spend another 30 minutes rambling about stuff that isn't important. I think Rust is fine. Rust is a good language, you know. I don't know. I just don't. The memory safety stuff doesn't appeal to me because I don't think it's that big of a problem in like real code where you're careful about memory management. So to me, it seems like a solution to a problem that doesn't really exist. And there's like in C or C++, I can, you know, compile with the address sanitizer turned on and then catch most of the memory issues I have. Except off by 1 issues, which I don't think Rust would save you from anyway. So I don't really know what I gain from using Rust. Sorry, I'm dilly-dallying around here. Assets. I want to draw little normal vectors on my shape. Just to ensure that this thing actually works. Yeah, let's give like a basic texture for this guy. We'll give the sphere the rat texture. Why not? We don't need a texture. All right, so just load this guy in. Well, the problem is games get slower. Most modern games don't have memory leaks. Like, memory leaks are super trivial to find and correct. That I just cannot believe that a large game engine or a big company would even make that mistake. And I know this from experience because I used to work at a AAA company. And like memory leaks are some of the easiest bugs to find. Especially if you're strict about how you allocate memory. Like memory can only leak if you're being lazy with how you're allocating stuff. So like how can memory leak? So you basically either, if you're using malloc and free, you're not calling a free when you should be. If you're using like C++ new and delete, then you're not using a delete when you should be. It's like, okay, that seems like it could be hard to detect. But like I don't know, like with smart pointers in C++, even though I don't even use smart pointers, that makes memory leaks kind of impossible unless you have like dangling references to these things. I mean, I guess that's possible if you're being lazy about it. But like you really shouldn't even be allocating stuff all the time in order for freeing to be like a problem. Like if you just allocate a block of memory for each system, you can't leak memory because you've allocated the memory for it. And then when the system's done, you free the memory for it in just one big block. It's not hard. I don't know why people overcomplicate this. Yeah. Sorry, I just get annoyed with the memory thing as well, I guess. All right, let's draw the sphere. So in the scene, we'll just draw this thing somewhere. Okay. I have a seg fault. See, look, here we go. We have a memory leak, right? But oh no, we caught it and we have a call stack to exactly where it happened. Like it's not a big deal. So like what happened? We tried to draw the model, but what, we didn't initialize it or something? Let's see, what was the error? Let's go into a release build. Okay, that did not help me. We don't want to be in release build, we want symbols. Speaking of memory, I'm hitting all these seg faults and it's so funny. But this is a good demonstration. You have mechanisms in place that catch these things, right? It's like, okay, I tried to access memory that doesn't exist. Let's drop a call stack. So like, what is it failing to draw? And that's a good question. I don't know what it's failing to draw. So it tried to do what? At the material. So it tried to find a material that doesn't exist. Okay, cool. So I need to give it a material file. So I will give it the rat texture, because why not? I guess it doesn't use the fallback material yet, so I need to fix that. So let's just copy the rat material. Why not? Oh my gosh. sphere rat.png. All right, here we go. What happened? Another seg fault here. This is a fake error though. All right, let's turn off. Let's go to the other one. Well, actually, that's not how you work, because you would just have a max size that you would never allocate past, right? And then you just deal with that case as an explicit edge case that you deal with. What happens if you try to allocate a string that's too big? Then you hit the max. It's like, okay, it's a condition that would trigger an assert. And then in the runtime build, you would have a fallback. Easy. You've handled it. Anywhere you use memory alloc, you just immediately think, okay, what happens if we allocate past some max size? All right, now that's a condition you check for. And it's like, you just do that all the time everywhere. And now you've like solved the problem. I'm gonna make my rat model a bit bigger though. Or my sphere model a bit bigger. Yeah, I don't remember how I get it. I have something in the debug module. You could look through the code. It's kind of a pain because each compiler actually generates the symbols in a different way. So you have to, like, based on the compiler, figure it out. So that's kind of annoying, unfortunately. Okay, so now we're going to go through each point on the model. And we're going to draw little debug lines for each normal point and so we can turn off this for each mesh. I guess model init is what I need. Oops. Here, this is what I'm looking for. This is what I'm looking for. All right, so for each mesh, we just iterate over. So these are our vertices. This is an array of vertices. So you look at this crazy, like, reinterpret cast nonsense I'm doing. You seen this? This is insane. Wow, so crazy. The index buffer is a U32 indices, so we get a U32 pointer to the array at this location in the file. So now we can iterate over these. So for I less than index count I plus plus. So the index count is just so const u30 index equals indices at I And then to get the specific vertex we care about, we can just do this is equal to vertices at index, right? Cool. Now we have the vertex. Now we can just draw a line. Is the vertex dot position, and then float p1 is the vertex dot position plus vertex dot normal times like 4, I don't know, some random value. So if we draw a line between 0, 1, give it 1 thickness, and we'll make this blue for the normal. Wow, look at all of our cute little normal directions, right? But maybe we want to do this, only have one of them per triangle, right? So here, let me turn the boat off. Because this normal is shared between 6 faces, you have like a triangle there, triangle there, triangle there, triangle there. Hairy ball. Yep. So now let's draw a line. We'll draw the line for, so P normal, and then we'll have the tangent line, P tangent. And we'll just see if this looks reasonable or not, because I actually don't know. Do those look reasonable? They kind of do. It's hard to say, because it seems like they're kind of collapsed along one axis. And I thought I got rid of the boat, but I guess not. So let's get the normal at the center of the triangle. Oops. And I missed a bracket. Yeah, the averaging did not work. What happened? Uh-oh. Oh, I didn't add P0 plus. And this should be in parentheses, of course. Here we go, each little face. It's kind of hard to see because I have depth turned off. Let me turn the depth off for the line. Well, let's make the line thickness a bit bigger. We'll make these a bit longer. Well, that didn't really help the case. Now it's just impossible to see what's happening. So let me turn depth besting back on. Here, we'll push P0 along the normal slightly. Or it doesn't matter. I'm not seeing the line because it's like depth testing against the face, so that's why the line isn't showing at all times. But I think this is correct. This looks correct to me. This matches my intuition of what it should look like. A cube would have made more sense. Yeah, well, I can do a cube next. Let me just push the point outwards slightly, though. So that way we can actually see the tangents. some sort of vessel. All right. Cube Taurus teapot. Really little expectation. Yeah, that's a fair point, actually. I'll do the cube. I can trivially turn this into a cube. So we will add the cube, scale it up so we can see, export the cube, and we'll name it sphere because that's not confusing at all. I need to do this again. I don't know how many are in the project. Quite a few. All right, so for each triangle, this seems to look right to me. Like the tangent is obviously along the face of the triangle, right? I should get rid of the boat. Minecraft rat. Hey, how's it going? How have you been? Let me get rid of the boat. I missed a comment in here. What the heck? How many times do I draw this thing? Wow. How many times do I have to comment out the boat? Nice. Yeah, I had off of work today because of President's Day. It's a federal holiday, and my employer recognized that as a holiday, which is nice. Yeah, because I'm not normally able to work on this stuff during the week. Look at the rat cube. That's what you should get. Okay, let me check this link out. All right, here we go. So the torus Is there a model associated with this? Let me just load the torus into Blender and see what I get. In add mesh torus. So we'll have the torus here. Here, I'll make this really big just so it's easy to see. Oops. Oh, my coordinate system is flipped from Blender's expectation. Let me make the torus a lot bigger. And then I'll export it in the correct up axis. I hate how I have to keep rewriting this material. Yeah, I'm surprised you guys don't have off today. It's interesting. All right, I mean, this looks right to me. You know, it's like I'm getting... It depends on the part of the tangents depend on the UV coordinates. So mine don't twist in the same way that it does in the picture, but I think that's because of the way the UVs are projected onto this thing is why I'm not getting the twist in my tangent space. Because I think this is correct. Mad Max wheels. Question, what am I doing right now? Sorry, I missed some questions. How many lines of code? I don't know. I'm doing tangents. I was calculating tangents from my vertex buffer for the model. Because, so tangents are these little red lines. The blue ones are the surface normals. And then from the tangent and the normal, I can calculate the bitangent, which would be a third line going up. And then I can use that to basically define a coordinate space for which I can apply normal mapping. So when I do lighting calculations, I am still going. I'm going to take a break in a second here, but I might continue on a little bit this evening. I'm not sure yet. But yeah, so I have lighting going on here, but this isn't accounting for normal mapping, so it just looks really smooth. So I need the tangents for that. Oh, yes. Yeah, I got the neighborhood map going. It's pretty sick. Yeah. So yeah, it's just doing a bunch of lighting stuff. The hood is in here. I'm glad that these work. Yeah, so in theory, I can, from these, like if I want to just visualize what the tangents look like, or the bitangent, I guess, I can calculate the bitangent So if I have a t in here, float t would be this. I could do p bitangent. Make this guy green. So in theory, the bitangent should just be the float v3 cross product between n and t. Yeah, I made the map quite a while ago, actually. I don't see anything. What'd I do wrong? Oh, B. That would explain it. Yeah, so now we have 3 vectors which describe a coordinate space that exists on the surface of the shape, basically. So like if we zoom the shape up to be like infinitely large, right? As if it's like a planet. It's like this would be your coordinate system for, you know, the shape. because a normal map is just an offset within this coordinate system along its like outward vector. Copy pasta disaster. So that's interesting. Yeah, quick going. It hasn't been too quick. I spent way more time than I should have getting the bitangent calculation to work. It's because I was like getting confused with the way I was doing my index buffer. But thankfully from this I can calculate normal maps pretty quick. So I'll be able to get that done tonight. I might take a bit of a break though before I work on that, just because I'm getting hungry and I've been going for 6 hours. I need to get up and move, otherwise I get like, I don't know, back pain. The memory issue talk. Yeah. I forget, who was I arguing with in there? Was it you? Who was I arguing with? I don't have names showing, so it's like, yeah. Oh yeah, no problem. Yeah, it's complicated, the lighting stuff. Well, it's not complicated, but there's a lot of lingo you kind of have to understand for it to make sense. So yeah, it's definitely, it doesn't really make much sense, to be honest, but it also makes sense once you understand the coordinate system stuff. I can see names. I just wasn't looking at the names earlier. I made this map. I made this map like 10 years ago. For one of the old games I was working on. With Mishmash, who's in the chat, actually. Me and him worked on the game like 10 years ago. And this is just one of the maps. And actually, what's interesting is this is my like real life neighborhood at the time when I used to live here. I don't want to dox myself, but I don't live here anymore, so it's fine. But I made this map as like a 1-to-1 copy. Obviously not with all the debris and stuff. But the houses and stuff are like... hopefully with less guns. Yeah, there weren't as many guns back there. But you know, it's America, so there's probably a lot of guns. The tank was definitely there. Yeah. Okay, I'm pretty happy with the progress today on this, even though it was slow going for a while. And everyone clapped. Everyone's got guns in America. Yeah, what to do next? I guess the next step is obviously to do normal mapping. Nice. You know, in your defense though, I don't even have an asset browser. So that's more than me, you know. My asset browser is the VS Code file manager. And manually edited text files. Every time I add a model file, I need to like add 4 files and a JSON. So it's not a very sustainable it's not a very sustainable system for large scale projects. But it's fine for now. But yeah, this map, I have a YouTube video on my channel. Sorry, someone's messaging me on Discord. The arm model does change with the weapon. I don't have skeletal animations in yet. So yeah, I don't have. I'm just each gun has an arm model associated with it, so it changes depending on the gun. It's very simple. What features am I going for with the lighting system besides normal mapping and shadows? So I right now I'm just getting the fundamentals implemented. So I implemented shadow mapping between yesterday and today. So I have cascaded shadow mapping, and I can turn the debug on for those. So here are like my shadow map cascade levels. So the red one's the highest quality, the green one's like the next highest. There's a blue one. There's also like a orange one, I think, or some other color further away. My far plane is super far. Oh, it's pink. So I have shadow mapping, and now I'm doing lighting, like point lights. I'll have spotlights and all of that fun stuff. But everything I'm doing is like very inefficient currently. So I'm just doing forward rendering, which means I'm just rendering everything in one pass. So like all the lights are technically calculating lighting for every single pixel, for every single light. So like each pixel is calculating up to the number of lights I have in the scene at the moment. So I will definitely be optimizing this to probably use a deferred renderer, or maybe a forward plus renderer. A forward plus would be better because it simplifies dealing with different materials and also transparent things. So forward plus is probably what I want to do. I'm not sure yet. And then I'm using just like specular lighting. So like Blin Fong, I think is what it's called. But I will probably want to do like PBR lighting instead. So I can use like physically based materials that more properly account for like reflection and metallic materials. Yeah, so deferred, yeah, it's interesting. So deferred is, it's an optimization in that you basically render all the scene to the G buffer. So you have like, you just render the scene twice basically. And the first pass just caches like all the color pixels, all the normal maps. Yeah, forward plus is definitely what's the go-to. So yeah, the G buffer, it basically, you cache the scene into a G buffer. And then in the second pass, you reconstruct the scene essentially from the G buffer. So you'll have the depth map, you'll have the colors, you'll have the normals. And then you apply the lighting calculations to that reconstructed scene. And the benefit is that the number of pixels you'll actually have to calculate lighting for is like fixed with the size of your render target basically. So like if you have a 1080 by or a 1920 by 1080 G buffer, you'll only be like performing pixel calculations, shader invocations for that number of pixels. And like it's an optimization because then you can mask your lights, so you only calculate lighting in the pixels where the light actually influences it. You don't have wasted calculation with like overdraw, because with forward you can imagine like there's this light being calculated here, and if I hide behind the tree, the GPU will potentially render these pixels with the lighting calculations and then immediately have to like discard that work with the stuff that draws in front. So you still pay the cost of drawing the stuff behind it, and then you just immediately overwrite it. So you don't have that problem with the deferred renderer. The downside, though, is that you can't really do transparent materials very easily without essentially writing a forward renderer that runs on top of your deferred renderer. So you would have like a deferred renderer for all your opaque stuff, and then a forward renderer for your transparent stuff. So it's actually more complicated for that sort of thing. And then also having a bunch of, like if you have a bunch of shaders for different materials, that's a bit trickier with a deferred renderer, because you would need to figure out a way to invoke different shaders depending on where the material is. So I think like typically a deferred shader just has like one huge shader that runs, and then it branches based on like a material flag or something that you also store in the G buffer. So yeah, there's pros and cons. Yep, exactly. All right, so I'm probably going to take a break for like 15 minutes. And then I'll come back. But yeah, I'll keep the stream up because I'll be back in like 15 minutes probably. Yeah, depth pre-pass certainly helps. Because yeah, you could just discard triangles that are you know, not visible, right? But you still have a bit of triangle overdraw because you don't want to like fully discard a triangle if it's only partially, like you can only discard like fully occluded triangles, I guess, with a depth pre-pass. So you still pay a tiny bit of cost, but it's not significant. Oh, does it work per pixel? That's interesting. Yeah, maybe I was thinking of something else. I don't want to talk too much about like proprietary engine technology, but where I used to work, we had a depth pre-pass that was on the vertex. It was like per triangle. So we had like a depth pre-pass that rendered the scene, and then in a compute shader, we culled triangles based on the pre-pass depth buffer. So maybe I was thinking about that. What we did wasn't per pixel. Yeah, I'm sure you'll pick up graphics pretty quickly, though. I wouldn't be too worried about it. Learn OpenGL. Yeah, but I want to get tonight before I end the stream for good. I want to get normal mapping in, and then that'll be a good ending point, I think. Should you go for a ray trace renderer? Depending. That's an interesting question too. I mean, one could make the argument that I should be like, maybe I should be going for like Gaussian splatting or whatever it's called now. There seems to be a lot of development happening in the Gaussian splatting rendering scene. So like if you did ray tracing with like Gaussian splatting, you know. Yeah, that's an interesting point with the vertex format. You could have one that has position. Yeah. That's true as well. Yeah, because you have to store this huge like matrix of Gaussian splat information. You know, but if I was gonna say if RAM just keeps increasing, maybe, but it seems like RAM is kind of stagnant. So, yeah. It's interesting chat. Only thing increasing with RAM is the price. It's all forward plus. At least from my experience, everything is forward plus now. Because forward plus has so many benefits to like simplifying a lot of the other parts of the rendering pipeline. So yeah, I think the preferred is forward plus. Deferred is kind of arguably dying, I think, but it's fun to write deferred renderers. So, yeah. I need to fix my shadow cascades. They look pretty rough. All right, but I'm going to step out for a second. I'll be back in like 10, 15 minutes. So let me make a note. Here, I'll get myself in a nice position here. I just need to take a bit of a brain break. I'll leave the stream going though. The classic notepad. All right, so I'll be back in a bit. Don't hide the rotating rat. All right, let's get the rat in. Let's get the rat visible here. He's kind of visible. All right. Okay, see you guys in a bit. All right, I'm back. Let's do some lighting. Let's do some normal mapping. And then we will call it a day, probably. Because I've been going on the stream for a while. All right, so what engine is this? This is my own engine. So yeah, I've written my own game engine. All right, shaders. We have a tangent and a normal now. So the TBN matrix is what? Oops. So how do we calculate this thing? We have basically these vectors multiplied by the model matrix, and then we store that in a 3x3. First we transform all TBN vector coordinate system. Now we have TBI matrix. How are we going to use it? Tangent space to world space. Or we take the inverse TBI matrix to transform any vector from world space to tangent space and use this matrix to transform not the normal but the other relevant lighting variables to tangent space. Did I go for a little jogging? No. So I want to do the first one, I think, because I just like working with vectors in world space because that's where my lights are stored. We can multiply the sampled tangent space normal with this TBI matrix to transform the normal vector to the same reference space as our other lighting vectors. So we just generate this thing. So our out has to have a float 3x3 TBN. I'll say matrix TBN. And we'll have a float 3x3 matrix TBN. And our out dot matrix TBN will just be a float 3x3 what is this? Do I really send this in piece by piece? That can't be right. Do I really keep showing up? I don't pay anything. I am not paying for YouTube. Okay. Are you sick of seeing me in your For You page? If you're not interested, I think there's a button that says I am not interested in this. And then hopefully I stop showing up. Unless you are interested, then yeah, that's great. Okay, so we calculate the normal and the tangent into our model space. And then we have to calculate the bitangent from those. So we have a cross of the normal with the tangent. And that should get us our bitangent. And then I think it's just like, what did this say? Tangent, bitangent, normal is what? I guess I'll just normalize all of these, even though I think they're fine. Let's call this NTB. All right. So what order does this want? I don't even know how to test if this is correct or not. So TBN is TBN, of course. So TBN. Does this compile? I don't know. We'll see. It does not compile. Cross. Implicit truncation of vector type. So XYZ. Or no, this should be... Wait, what? What just happened? Cross. Implicit truncation of vector type. What? Where is it truncating from a float? Oh, I see. Here. What? Does cross only take a vec3? Here, let me do this. That'll make more sense. Because we don't want a for component for that. Okay, so in theory we have an MBT TBN matrix now. So if, what does this say? So if we multiply so we calculate the normal and then we multiply that. And then normalize. No matching two parameter. So what is this? This should be dot XYZ. What's the problem? Is this not a float 3? How does this not work? I'm literally doing the same thing up here. Oh, I'm not multiplying. What am I doing? Duh. I'm like, why isn't this working? What is happening? Okay, will this just magically work? Is the question. Oh, sick! Look at that. That's looking normal mappy to me. Is it looking correct? I don't know, but that looks like a normal map is being applied. It's hard to tell with the lighting with the sun turned on. That looks like normal mapping to me. Like, oh, well, the highlights are on the wrong direction. So my normal map is inverse of what it should be, I think. Because I'm like getting lighting. Well, that side looks fine. Maybe it is fine. It's hard to tell, to be honest. I thought it was going backwards, but it's kind of hard to tell. I need some materials that have more obvious normal mapping. Like that looks generally correct though, because we're getting like, we're starting to see the texture of the material more now. Like you see you have these highlights on only certain bits of it. And that's what normal map looks like. Like, look at this. You see how it's like shiny along the little bolt here? So that looks correct to me. Yeah, that's the normal maps that do that effect. I'm not sure if they're working 100%. They might be flipped. It's kind of hard to tell. This is like a horrible model to test it on because it's like, you know, it's impossible to tell if that's right or not. Let me turn off this crazy debug rendering thing I have going on. I think my normals are inverted, actually. Again, it's hard to tell. I need like a better material. Yeah, I need a billboard. Well, I don't know. It's tough to tell. It's hard to say. Like, this looks much better, though. Yeah, I think it's right. Because look, if I, like, place the light... let me turn the light, the shadows off. Because the shadows make it hard to see what's happening. And I just spawn a light here. Oh, that wasn't in the right spot. See how it's like the shadows are here? Because this is like supposed to be corrugated, so it like sticks in. And we get the highlights on the right face of this little corrugated metal. I think it's working. Yeah, I think it looks good. Let's test OpenGL, so just make sure Yeah. I think it's fine. I need some better models, of course, to actually get a better grip of what's happening. But let's make sure it looks the same in OpenGL, because they use different shader language, so you never know. Sometimes they flip signs. It looks good to me. This looks right. Like, that looks pretty good, like this. It's a nice depth there now. PBR, yeah. What's the goal for this game? So this game is primarily just to drive the engine tech forward. It's just fun making a little FPS game too. But I'm mostly just working on graphics stuff at the moment. And there will be a part of this where I'm starting to do some netcode as well, because this is a multiplayer game, or it will be a multiplayer game. So it's like graphics and netcode basically. It's just forcing me to add stuff that I haven't been focusing on with the engine yet in the graphics department. It's interesting how this like suddenly cuts off. So I don't have spotlights implemented, so this is like something weird's happening here. Not sure what's going on with that. I mean, it looks neat, but that's not... I don't know what's happening with that specifically. That's weird. I could make the light bigger, yeah. I'll need to figure out what's going on with these point lights. It's like the distance attenuation has broken. Or the normals are like doing something weird. It's hard to say. I think maybe it's using the fallback normal map, and that's causing like a weird directionality to the lighting. Maybe I should have a default normal map texture. Because I think the lights over here work fine. Yeah. All right. So that's exciting, having all that stuff in there, in the engine. Yeah. The map isn't loading normal maps, so I think it's using just basically garbage textures and then calculating the lighting from that, so it looks pretty bad. So I don't have normals for the map here. I only have normals for these models. So what I really need is a test map that has actually correct materials. And I can start doing cool stuff with that. Yeah, I should get Sponza. That'd be a good idea. There was a way they worked out infinite lighting with shadow mapping. I think... I don't know what you mean by infinite. Yeah, no problem. Don't worry about missing the stream. Let me turn the shadows back on. Oh, yeah, more than 8 lights. Yeah, Yeah, so that was like, I don't know if you were here before when we were talking about deferred versus like forward rendering or forward plus. So yeah, the technique that was like traditionally used for that was it's called deferred rendering, where you can basically have a ton of lights. Because the problem with, so what I'm doing here is forward rendering, meaning I'm just rendering in one pass. And I'm calculating light for every pixel in the scene for every light source. So like every pixel has lighting calculations for every light source. And you can imagine that that gets really expensive. So yeah, this doesn't scale. You know, you can have a small number of lights and it's fine, but it doesn't scale. So what they, basically the technique that people have used to solve that for a while was deferred rendering, where you have like a 2-pass rendering stage where you first render the scene basically into a G buffer, it's called. And then in the second pass, you basically reconstruct the scene from the G buffer, and then you perform lighting calculations only on the pixels that were visible in the G buffer. So then you have like the number of pixels you have to raster with lighting is smaller, and then you can also mask the lighting. So you only render pixels with lighting where they're actually being affected by lighting. So that allows you to do masking. But there's a lot of other problems with the deferred renderer. So nowadays, the technique that most game engines use is a forward plus, it's called, which is kind of a hybrid between a deferred renderer and a forward renderer, and that you still render everything kind of in one go, but you have your scene kind of bucketed down into smaller little clusters, and in those clusters you can like create a data structure that contains, you know, is this cluster of pixels affected by this light source? And then only those pixels have to worry about the light sources that affect it. But it's more complicated to set up a forward plus renderer, but it's beneficial to make one. And you can do other sort of tricks with it as well. So it's, yeah, like you said here, it's a good mix of both worlds. Yeah, because like one of the downsides with a deferred renderer is you can't easily do transparent materials because of the whole G buffer thing. Because the G buffer only stores like the closest surface to you because of the depth buffer. Yeah. So it's interesting. There's like many ways to do it. And then of course you have like other rendering techniques. So like Unreal Engine has Nanite, which is an interesting technique of, well, that's kind of separate from rendering, I guess, because that's more about how they do their level of detail system. But that's an interesting thing. And there's like Gaussian splatting is a new technique that's pretty interesting. And then ray tracing, of course, is another big rendering technique for lighting. And I'm sure there's others, like voxel rendering. People really like voxel rendering too. So there's a lot of ways to solve the rendering problem. And it's kind of like, depending on how complicated your scene is in like your material system and how much geometry you're drawing, kind of pushes you in one way or the other. Yeah. And like voxels make sense for like ray tracing because it's like it's cheap to ray trace into voxel grids. So like a lot of renderers that have ray tracing kind of do have a crude voxel rendering implementation as well. Or at least like a data structure that represents the scene in like a lower resolution voxel form just for the ray traced lighting, which is interesting. So yeah, you can definitely go super complicated. What I have here is very basic. Very simple. Yeah. Yep. That's true. I mean, I've seen some really impressive voxel renderers. Yeah, it makes sense. Nice. Yeah. Mirrors are interesting. Yeah, because reflections are like the main, like a huge upside of ray tracing is you get accurate reflections. You don't have to use like cube maps or screen space. Yeah, I can imagine doing more GPU rendering. I want to, I definitely want to experiment with that at some point. Maybe in the engine, I'll get the renderer to a point where I have the modern features so I can do more GPU-driven rendering in more complicated pipeline. Or a more GPU-focused pipeline. Because that could be really interesting. Like, I don't know what my frame rate is. What's my frame rate right now? Yeah, so I only get about 400 frames now rendering this scene, which is, I have a decent computer, so that's pretty bad. Well, I'm in OpenGL. Let me go to DirectX. Maybe it'll be a bit quicker in DirectX. It'll probably be around like 800, I guess. But I have a decent GPU, so I should be going a lot faster than 800 for a scene like this. 1300. That's not bad, actually. For a naive implementation, it's actually not too bad. Let's get more lights in the scene. It should be a lot quicker, though. Yeah, OpenGL is pretty horrible on Windows. I'm sure my OpenGL backend isn't the most optimized. I think I have some of my state management could be better, I think, but it's pretty bad on Windows. Now my computer's like turning on. How do you do sound? I don't think I'm CPU bound. I would be surprised if I'm CPU bound. It's possible though. I could profile it and see. I have other games that run way faster though, so I don't think CPU should be the problem. Like if I go this project, I get really high frame rate in this one. So this is my little asteroids game. So this is DirectX. I'm getting about 9,000 frames. Obviously the compositor isn't actually rendering at 9,000 frames. It's probably just discarding most of them. But if I go to OpenGL, let's see what I get in OpenGL. See, like in this game on OpenGL, I get about 6,000. So like, I don't know. This is obviously a simple game where I'm just rendering some sprites. But on the CPU, this isn't doing much more than the other game was, so I'm really not sure what's happening. I don't know why the text is drawing at the bottom of the screen. Let's see what my Terraria clone gets. I haven't profiled this one in a while. Well, that wasn't even on a release build. That was a debug build. Let's see what my Terraria clone gets. Like my Terraria clone with the water simulation runs at like 1800. So, and the water simulation is a pretty intense computation happening on the GPU, of course. So it's, and lighting too. It's doing lighting. It's a bit slower if I go in full screen, because the render targets are larger. It's the 3080, RTX 3080. Sound from scratch. It's funny you say that, because I actually do have my own sound library that I wrote from scratch. But I wouldn't recommend it because it's a pain in the ass. But I use like the Wasapi API on Windows for sound. And I have like a sound mixer thread and a whole audio layering system. Let me get to the engine audio. So like I have my audio mixer. So this is the function that actually deals with mixing audio. And it's mono and dual channel, and it also supports streamed sounds like music. And I have like a bunch of effects that can be layered on top. What's up? What's up? This has just been a long time coming. And on, I believe this is Apple. So on Apple, you use Audio Toolbox. So it's this core audio system library thing. And on Linux, I'm using ALSA Audio. Now the backends for this are actually pretty simple, because all these things expect is a mixer thread, and then you give it like an audio buffer, which contains your samples. So how loud your audio is. So like if in audio, you'll see that there's like a frequency. So most sounds are like 44,100 hertz, or 48,000 hertz is another common one. And what that means is that essentially you have an array of values that's like 44,100, long for every second of audio. And each individual sample is just a floating point value, or like an integer value representing how loud, how loud the sound is. And then your speaker just plays that. And then our brains interpret that as sound. So it's actually not that complicated. You're just sending it a giant buffer of, in my engine, I use integer sound. So I have 16 signed 16-bit integers for the sound value. And that's interesting. But I use the sound in this project for like the water sound. I don't know how much it's coming on stream, but there's like dynamic water splash sounds that play based on the fluid simulation. And if I go into the water, it like muffles the sound. So I can play one of the soundtracks. Again, I don't know if this is loud enough on the live stream. It might be pretty quiet. But if I go in the water, it like muffles. Yeah, the water, it's a technique called reintegration tracking that I implemented, that I didn't invent. It's by this guy. I don't know how to pronounce his name, but he's a pretty popular computer graphics guy. And it's my simulation basically implements this algorithm. I've changed it a bit just for the game. There's like a few things I've changed. But it's essentially based on the principle of this algorithm. So yeah, that's how that works. It's GPU algorithm, so it runs. I'm doing, it's kind of stupid how I'm doing it right now because I'm simulating it in a fragment shader. And the reason is I didn't have compute shaders implemented yet into the engine. So I should be using compute shaders for this, but it's actually in a fragment shader at the moment. I've yet to port it over. It's because when I was working with OpenGL on Mac, Mac didn't support the version of OpenGL which has compute shaders, and I didn't have Metal yet, so yeah, that's how that works. Arguably, it's harder to implement it through a fragment shader, so maybe that's a flex. I don't know. Because I need to like pack my data into like the RGBA channels. But yeah, the audio is really cool with the water. I was pretty proud of this implementation. Because detecting and playing sound based on the GPU simulation is actually pretty difficult. Or it's not difficult, it's just an interesting problem to solve. Because I have to make sense of like what's happening in the simulation and like what sound should I play for it to sound like natural flowing water. And that's a really interesting problem. So I have a fun debug view which shows how the audio actually works. Oh, wrong one. Debug ambience, I think it's in. So if I make this like partially, I'm trying to get the time in the way where you can see it. So this is the debug view for the audio sound, like the water sound. So I have all these little dots scattered throughout the scene kind of equally. And these are like little audio sampling probes that basically read the simulation state and kind of spring around, I call it, with the velocity of the liquid. And then from these little probes, I can detect how much... I can just detect, like at a high level, what the general flow of the water is. And then from that, I can just create these little audio emitters, which are these white dots. So these are where sound is actually playing, like spatially. So like as I move water, you can see it spawning a bunch of these. And I can also detect splashes because wherever these little probes like clip into blocks, I know that that's a splash event because the water has pushed the probe into a block. And the speed at which it collides with the block determines like the intensity of the splash sound. So it's kind of an interesting solution to the problem. And you can see these zones kind of fade in and out, so they get dark. Like these dots are a little dimmer than these ones. Because it kind of, the system turns on and off depending on if there's like activity within the chunk. So it doesn't like, it doesn't scan all the time. It only kind of turns, it like wakes up as water starts to move. As a bit of an optimization. And this is kind of cool, just debug of showing how the water moves around. And I'm just going to show this off because I'm proud of it. But this game is actually multiplayer as well. So I'm still working on this. But I have the simulation working in multiplayer, which was really difficult to figure out, and I'm proud of it. And part of the reason I got a little burned out, so I've started the FPS project to like give my mind a break. Oh shoot. I might have just messed this up. Here we go. Okay, so we're in multiplayer now. And the water simulation syncs over the network, which is really cool. So you can see like between the screens. Oops, wrong block. Like I can pick up water, throw it around, see how it's like showing on both screens. So that was really tough to sync the water simulation over the graphics card, like over the network. Yeah, so yeah. How long have I started this project? So this game I've been working on for like a year. It's hard to sync because this Katara waterbending. Yes. I should add earthbending and firebending. I'll make Avatar Terraria version. So it's hard to do this because there's like many layers to this problem that I need to solve. So the first is that my world is broken up into chunks. So here's like the chunk debug view. So my world is in chunks. I'm 27. Yeah, so the world's based in chunks. So one of the problems is that I only simulate the fluid that's like around the camera, right? Because as just a performance thing, I can't simulate the entire world at one time. So I'm forced to simulate only a fixed region around the player. So you can imagine situations where you have a server with people in different locations. So they're simulating basically different sections of the world, right? And they're simulating their water. And then say they walk close to each other. And now you simulate, so you're simulating two regions, and now these regions overlap partially, right? And then imagine a situation where one of the regions has a giant wave flowing through it that flows into the overlap zone. But from that player's perspective, its simulation ends after a certain number of chunks off screen, but the other player continues, right? So you can imagine this overlap where the wave has to flow between zones. That's really tricky to solve because how do you simulate the water if you can't simulate it throughout the entire world at the same time? So that's a problem I had to think about. I had to think about that a lot because that really complicates things. Yeah, I'm 27. So that's one of the problems. The other problem is that the simulation is not deterministic, actually. And there's reasons why that's true. And there's solutions that can make it deterministic. I just decided not to make it deterministic because it kept it simple. So the one reason it's not deterministic is because I do the simulation with floating point math on the graphics card. And floating point math on the graphics card is already somewhat flaky in terms of its precision. So that already is a red flag for determinism. So it's not deterministic. You can make GPU floating point deterministic, but then you're still not guaranteed that between GPU vendors, the floating point arithmetic behaves the same way because the GPUs are like optimized for rendering triangle data. It doesn't need precise floating points, right? So that's another reason. And then the timing of like world updates. So like when does the simulation see a block influences the deterministic nature of how the water flows. So you get like latency timing over the network if you place a block and on your screen you see it placed immediately, but the server sees it 100 milliseconds later. So ultimately, long story short, the way the network simulation works is the server simulates basically all of the chunks around every player in the scene. So the server needs to be a somewhat beefier computer, and that's kind of just a requirement of the system. So the server simulates all of the water. But the clients still locally simulate their water because you want to be able to see the water behave immediately on your client when you do stuff, just for like the visual aspect of this. So the clients simulate their water locally, the server simulates it authoritatively. And then there's a mechanism in here which basically can check with like a cheap heuristic. It can compare a client's water state per chunk to the server's water state. And the server has like the ground truth state, right? So that's like what it needs to be. And if a client diverges from the server past some threshold, some arbitrary threshold that I've just kind of fine-tuned, then the server will force sync the client on like a per chunk basis to the server state. So if there's a time where the water desyncs significantly, you will see a pop in like your water as it like updates. But it's kind of lenient enough where it doesn't happen too often. And it would only really be a problem if you're on a really latent connection or there's like a ton of water movement. And I've decided that that's fine. Because it keeps everyone's water basically in sync. It prioritizes updating chunks that are significantly out of sync. And for the most part, it doesn't have to update too often. So that's how that works. Yeah, it's a hard reset just because it's difficult to interpolate the state. And I have tested. I've tested with a VPN connected to myself. So I've tested with like latency. And it works good enough, I think. Good enough for me to move on to other game things. And then how does Terraria solve this? So Terraria doesn't have a true water simulation. Well, Terraria has water, of course, and its water does move. But Terraria's water is like grid-based, and they have just a set of rules for how tiles move. So their water doesn't have like waves and splashes and like pressure and vorticity and stuff like this game does. So their water is basically a simple cellular automata, basically, that they can just simulate on the CPU, and they can do it in lockstep. Or I don't know how Terraria does it specifically because I'm not a Terraria developer. But theirs is an easier problem to solve because they can just do it on the CPU and just kind of guarantee that each client gets the same update interval. But since mine is on the GPU and mine's like I guess a higher resolution physics simulation, it's just not feasible to do it like that. So I have to do kind of a separate approach to like getting this to work. And actually on the screen here, you see this like number that bounces around. This is actually the size of the fluid simulation state for a chunk. So you can see like in the chunks that have a lot of water, the number goes higher. So it's about like 8 kilobytes for this chunk. And that includes oil and lava. Well, it jumped up because I added more liquid types. But this is the size of basically the simulation data that I need to sync if the chunk diverges. So it's kind of a big amount of data. Like 10 kilobytes isn't huge, but over the network that is a somewhat significant size of data. So I want to limit how often I have to synchronize. And the bottom number is the size of the chunk in like terms of block data. So the like a chunk is a lot smaller in terms of the data that it takes that needs to be synced. Like every time you like load a chunk, we need to sync this. But yeah, as like the water complexity increases in a chunk, you can see the number goes up. And this is a compressed number. So it's jumping around because the water is like compressing. It's like being compressed. And then, the efficiency of the compression is based on how chaotic, how noisy versus how predictable the data is. Yeah, and that's certainly an option too. It's really interesting. It's a really interesting problem. I've been thinking about it for months. It was like a huge project in the second half of last year, getting this all working correctly. The thing is, I'm making a Terraria clone, basically. I say that in jest. It's not actually a Terraria clone. Like this game's gonna be a different game than Terraria, in terms of what you actually do, and all of that. But obviously, visually, it is a Terraria game. So it's like I'm competing in that space. So I like if I'm going to compete in the space, I need to bring something that Terraria or Starbound don't have. And I think the simulation side of things is something that would make my game stand out that they don't have. So I've been putting a lot of effort into this. And there's a lot of cool gameplay stuff I could do with the simulation. So I think it's cool. Like I can simulate huge bodies of water. Like this is a huge body of water as far as like a 2D game goes. And the cool thing is that this runs very efficiently. So like if I uncap my frame rate and I close the other instance of the game, well, I guess it's not running super crazy because I have the server going. So the server is doing a bit more heavy lifting, but it runs pretty efficiently. It's cool because the whole water, like the lake, you can drain an entire lake, and this is just really fun. I just think it's cool that like the whole system scales very well for this type of thing. I was hoping there was another cave down here. Here's a cave. Yeah. Yeah, Noda, or no, how do you pronounce that game's name? Yeah, they're definitely, obviously, yeah, they have a cool simulation. Theirs is more like pixel based. So, Noda. Nwata. I've never actually pronounced that game's name before, so I don't know how they pronounce it. I would say Noda. Yeah. Yeah, so, yeah, there is some interesting things in there with the fluid data. Yeah, so I'm still experimenting with it. Because it's interesting because with compression, you basically want repeating chunks of data, like repeating predictable chunks of data, because then you can compress those chunks into, a smaller representation. Obviously, that's what compression is. But the fluid system is inherently chaotic. So if I bring up the debug view for like the fluid position velocity, maybe. So here's like what my texture contains. Maybe I can pick one of the different ones. Particle pressure. So like this is the render target that contains the fluid simulations, pressure, and I guess just the pressure value. My cat's like on the desk. So as I add different fluid types, that's like I see them appear in the render target. And you can see that this is chunked off. So like as I fly through the world, I flew to a place that doesn't have water. You can see how it's like recycling chunks in this larger simulation volume texture. I go to a place that doesn't have water. Yeah, essentially, I have a version of the simulation that actually ends up in these textures that I use on the GPU. And then on the CPU, I have a version which splits the channels into like their base types. So like I have a pressure, I have a velocity, I have a mass, and I think that's it actually. It's those three other main ones. And I have a fluid type, which just says, does this cell contain which type of fluid? Okay, my cat is like bouncing around. So yeah, and then for compression, so I have a representation of those which are like interleaved. So like each block has those types accessible to it. And then for compression, I split it out so like all of the pressures exist in one chunk of memory. All of the velocities exist in another chunk. And I also, what's the word? It's like quantize. I transform it from floating point to an integer type, basically. So I like quantize, I guess, the values. So I'm not storing the full floating point precision. And I go out to a few decimal points. So that helps a little bit with like the actual compression. But I don't know. I'm still playing with it. I'm sure there's ways I could do it more cleverly. It's hard for me to show that. the GPU versus CPU thing. It's hard for me to demonstrate that. Like, here, let me... Yeah, the cat loves jumping on my desk. Let me restart the game and just go into the profiler. So I have a CPU profiler just built into the engine. So I can go to the profiler. And this shows me the breakdown of the frames. And you can see I have some really hot frames here. So like my frame graph is pretty spiky at the moment. So I need to fix this out. Yeah, fixed point. Yeah, that's what I'm trying to explain. Fixed point. And that helps. It's still not perfect because you still have a bunch of variation. Yeah, I do that, don't I? It's like I'm looking into my mind. Where is the thing I'm looking for? But yeah, here's my CPU profiler. And it's pretty spiky at the moment. You can see like the best frame is like 0.17 milliseconds, but the worst frame is about 3 milliseconds. And unfortunately, the worst frame is waiting for the simulation, the read back from the GPU. So I spend a lot of time stalling, and this is with asynchronous readback. So I'm not even like stalling, waiting for a flush. It's just like taking forever to transfer data for some reason. So like every so often, I do a readback in a frame, and that takes up the majority of the time. But the actual simulation update on the CPU is like super cheap because it's really not doing anything, right? It's like 0.03 milliseconds. On the GPU though, here, let me get the debug build on so we have labels in render doc. Okay, goodbye, cat. My cat is getting his crazy hour. Let's get the water doing something. We'll take a capture. So on the GPU and render doc, we can see what the frame is doing. And a lot of my frame is actually taken up doing lighting simulation. So you can see I'm using vertex shaders, or like fragment shaders still for both the water and the lighting. Because I have a bunch of stage that are just flip-flopping between... it's like doing a flip-flop simulation thing. So this is lighting, and then this is the water simulation. So the water simulation has two steps. It has a particle step and then a grid step. And then I have a scheduler that like tries to ensure that the simulation runs 100 steps per second. And that's just the rate at which my simulation happens. So it just so happens that this frame I captured is doing 4 steps between particle grid. And then RenderDoc has this little timer thing. I don't really trust this though because it seems to fluctuate all the time. But you can see like if these numbers are to be believed, between the particle and the grid step, and again this isn't a fragment shader, so this is like already inefficient to be honest, because I'm like doing pixel rasterization rather than just writing to a buffer. But on my computer, assuming that this RenderDoc timing is correct, it's about 200 microseconds for one step of simulation. So a full step is about a millisecond, roughly, if I'm doing 4 of these. So like this full frame is about 800 milliseconds, I guess, or 800 microseconds. And you can see the lighting is only about 20 microseconds per step, and I do a bunch of the lighting steps because my lighting system isn't too efficient. But that's for like the global illumination stuff that happens. So yeah, and like my total frame time, I guess, is 2.8 milliseconds in this shot. Again, if that's to be believed. But like I should really get this moved over to a compute shader, because you can see I'm using these textures. I have 3 input textures to the simulation, and then I guess 3 output textures. So it's like literally rasterizing pixels from one to the other. But with a compute shader, I could do this significantly more efficiently. But it's still not slow. Like it's already fast doing it the inefficient way. So, yeah, it's just there's a lot of room for improvement left to be had. So that's kind of exciting in terms of gameplay features, because that means I have a lot of room for other features, obviously. Yeah, and this is running DirectX. But the cool thing is I can change the graphics API, so I can like do OpenGL instead. Oh, what global illumination? We're waiting. So like OpenGL. So now it's running OpenGL, which is cool. It's a bit slower. But let me just demonstrate. So the cool thing is that I can switch between them. Oh, it didn't grab the frame. Compute shaders, yeah. I need to get to that point. Oops, I hit the wrong button. OpenGL is a lot slower. But yeah, now it's doing GL draw element calls, and a ton of them, it looks like. Well, it's not that significantly slower. It still is like 21 versus 26 microseconds, so we're about 20% slower on the lighting update steps, and I guess about 20% slower on the particle update or the water update steps. Yeah. Well, you know, the fragment shader stuff is actually the fragment shader stuff, you know, was what people did before compute shaders, right? So, yeah. So nowadays people use compute shaders. The only reason I'm using fragment shaders is because I started working on this project before I had Metal implemented on Mac. So I didn't have access to compute shaders on Mac yet. And I use my MacBook so like I only have a MacBook laptop. So when I'm not at home, I'm on my Mac. So I still wanted to be able to work on the game when I was on my Mac. So I like purposefully limited myself to using fragment shaders for the simulation, just so I could maintain I could continue to work. Oh, and then sorry, what global illumination do I use? So I don't want to toot my own horn here, but because I don't even think this is very good of a solution. But I invented my own global illumination technique for this game. I think someone has probably come up with this before though, so like I don't think it's that crazy. But basically I treat light like a gas, essentially. It's pretty simple. Like you can see when I create a light, you see how it kind of expands in, right? Like it doesn't appear immediately. It kind of expands from the source point. And that's because it's like physically expanding into the space around it. So it's like a temporal expansion sort of algorithm that's happening. And that's why on the GPU, when you looked at the capture, oops, what just happened? I don't know what just crashed. That's why if you look at the capture here, I have like 1 million. Yeah, it's essentially a flood fill. I have like 1 million calls to the light update because in order for the light to appear kind of snappy when you create new ones, you need to do this flip algorithm, like this flip simulation many times per second. Thankfully, it's cheap enough where it's like doing it many times. It's still basically no frame time. But it's not very efficient because there's like a lot of overhead in doing a draw call. So like each of these update steps is a draw call basically. It's not C. Yeah. That's interesting. So yeah, that's this project. I don't even know why I was showing this project. Someone asked a question and I pulled this project up for some reason. But yeah, I need to do compute shaders for that project, so that'll be something I work on at some point. It's not really a bottleneck to me making the game anymore, so I don't know how motivated I am. I'll optimize it when it becomes a problem, I think. But for now, it just works fine. Why waste my life making this engine? It's not wasting my life. I just do this for fun. It's a hobby, right? So it's like, I already work a full-time job and I make money doing that. And I like programming. So like, I'd either be making this or I'd be making something else. So I might as well just make this, you know, it's fun. So I don't really think it's a waste of my life. Plus I'm learning a lot, right? So it's like, it is benefiting me in my career, I suppose. Yeah, I already have sound. I just showed that. You might have joined after I showed that. So like if you turn your sound on. Let me find some water. I already have sound. Here, listen to those wave splashing effects. Sound pretty nice. I go underwater, it gets more muffled. Yeah, I programmed the water physics. I just had a big rant about this like 10 minutes ago. So I won't do the same explanation again, but yeah, I was demonstrating that. All right. We'll be playing Halo. Well, yeah, I don't know. I just seem to have a lot of energy, I guess. I didn't have to work today either, so I've been streaming. But most days when I'm working, I'm not doing programming outside of this. So this is kind of like whenever I have energy, I work on this. So that's why it's taken many years to get to this point, because it's like I only have so much time in the day. So no, I haven't used geometry shaders yet. At some point I will. At some point I will. Yeah. Sorry I'm not really doing too much on the stream anymore. I've accomplished my objective for today, which was to get lighting working in the other engine, the other game. Like, look at this crazy water simulation. I love how you can see the high water velocity kind of show up through the color. I should make the water look a bit nicer though. The solid color maybe is, I don't know, it could maybe look better if I had a fancier water shader for the visuals. Are geometry shaders new? Or are they old? It's mesh shaders which are the new one, right? I've heard people talk about like mesh shaders. Unless it's geometry. I don't know. I'm most familiar with the vertex, the compute, and the fragment shader. Because those are like the only ones that actually, yeah, like those are the only ones that actually really do things I care about, I guess. Yeah, there's little light shafts with the water too. So the lighting system is also interacting with the fluid simulation. So that's kind of fun. Yeah, meshlets, mesh shaders. Yeah, those are the ones I'm thinking about. I should really add more gameplay to this game. Because I have a nice like base now, but there's really nothing to the game itself. So I need to start focusing on that. I spent a lot of time on like systems and not as much time on actual content. All right, yeah, see you. Thank you for stopping by. I'm probably going to cut the stream soon here. I've been going basically all day, and I have to do other things. I can't sit all day in front of the computer, so we're going to probably end the stream at some point. I have this little grenade I can throw too. I forgot about this. The grenade is fun. Yeah, it's cool. Yeah, mesh shaders. Just mesh shaders. Oh yeah, definitely the voxel world helps a lot, actually. Because I simulate the water in a grid. So it's not using particles. It's actually it's simulated in grid cells. So that helps significantly with the water because it only has to deal with like axis aligned collisions and stuff, which is super convenient. I need to do transparency for my depth buffer. I didn't realize my leaves look like hard faces. Or my shadows look like hard faces in the leaves. Or my leaves look like hard faces in the shadows. I'm speaking backwards. Yeah, 3D math is interesting. I think I have a decent intuition for it now, but like definitely the math is not my strong suit. The lighting looks a little weird in this now. I think I broke the lighting. It's like not rendering correctly. Or something weird is happening. I guess I'm in the shadow, so it's like, I don't know what's happening. What other projects do I have? I have the globe example is another fun project I was working on for a little bit. This is the demo project when you download the repository. So this is a fun little globe renderer. And this one's cool because it has like ray marched clouds. It's kind of hard to tell on the stream probably. But the clouds have like actual depth to them. And there's this aurora up here, which is kind of cool. This is a fun little demo project just to show off the graphics and stuff. I have a limit to how far you can zoom in because I don't actually render the Earth to any high degree of detail. So it's kind of just a sphere with an Earth texture. Looks good from a distance. But yeah. It's kind of fun doing the clouds. Not physically accurate either. I'm just like approximating values for them. Yeah, I can talk about that briefly. The main reason is compile speed. So like I've prioritized fast compile times just because it's just one of the goals I had for the engine was it should be able to build very quickly. And the standard library is kind of the opposite of building quickly. So I decided I would just not use the standard library so I don't have to include any of the standard header files, which significantly speeds up my build times. So like I can demonstrate just how quickly the game builds. If I go into if I build this thing from the terminal, oops, wrong module, wrong source. Yeah, so I can build the game from the terminal with my little batch script. So when I hit enter here, we'll do a full build, clean build, nothing in cache. And it's going to build all the assets and all the object files, all the shaders. So this is how long it takes to build the whole game. All right, that's it. The whole engine just built. I'm now running. Brand new, fresh build, no cache, no incremental build. The whole thing finished in 1.6 seconds. And you can see it actually compiled 2 different projects. So it did a compile here for the build tool, this build executable. So it compiled that, it ran the build executable, and then it compiled the game's runtime executable. So it did another compilation, 55 translation units, 41 up here. So total of like 96, plus it built the assets in a second and a half, basically. And this is because I don't use the standard library pretty much. And I'm careful with the headers I include. Among a few other things. But that's the main reason, is that I can have just very fast incremental build times. And then like if I go in and just change a shader or something. So if I go in this and just want to like edit something. So we'll like edit the atmosphere shader. Or the composite shader maybe. So we'll make the globe render in red. This is my classic example I give. And I just recompile this now. Now the globe is red. And that was how fast it took to like update that asset type. So I can like go back. Maybe a shader is not a good example because shaders are typically hot reloadable in engines. So you would expect it to be fast. But it's just like just being able to build a huge project. And like I can build my other game, Vitality. So this will do a full build of Vitality. And this is a release build too. So this is with optimization flags on. Oops, this had cache. Let me clear the cache for Vitality real quick. Okay, so now it should do a non-cached build. So this is building the other game I was just showing. Faster. That took a second and a half. To compile and build all the assets for this entire project took a second and a half. That's incredible. So yeah, that's why I'm not using standard basically. Yeah, and like I guess there like with a game engine, there's different ways to do game engines. So like you could have your engine as like a static library or something, or a dynamic library where you're not recompiling the whole engine every time you compile the game. So I compile the entire engine into the game. So like I'm compiling all the engine source code and the game source code. So I pay the cost of the entire engine build at the same time. And I just have it set up like that because nice. I assume you're from Japan. Hello, hello. Yeah, so anyway, I compile all the project sources or all the engine sources into the game. And Mostly because it's just easier for me to set it up that way. Because I'm like still working on the engine as I work on the games. So it's just easier if I just compile the code bases together. There is some optimization in that, but it's not really a big one. Like compiling the game's source code into the game does give the compiler more context to like optimize across translation units, or the linker, I guess. But you can compile a static library with like the extra information for the linker to do that. So I guess it's not really that's not really a problem. Not if you're. They're also a problem in AAA. I can say that from experience. Our compile times where I used to work were like 30 minutes for a fresh compile. So like if I did a non-incremental build compile, it was like 30. It was over 30 minutes to compile the game. So yeah, that was. I think that was a huge problem. So when I started this engine, I wanted to not have that problem ever be a problem. So I prioritized the compile speeds. And that's just, you know, it's fun. I guess I just enjoy doing that too. It's kind of fun to profile compiler times, compile speeds. Yeah, right. Like, this is kind of interesting because I also go a step further in this engine. Arguably a step too far, but I think it's fun. So I even have my own like trimmed version of the C header files. So for instance, I don't know, like here's the Windows header files. So these are the ones you typically include in your project if you're using like the C headers. So I have a version of the Windows header file which just like has my own kind of trimmed down version. So this is only the stuff I use in my engine. So if in development builds, like in debug builds, I'll compile with this version of the header file. But I have this macro where I can conditionally compile using the official ones. So like there is some cost in maintaining this header file, but it's significantly less code that has to be parsed and compiled and linked. So it actually is, this increases my compile speeds by about 2 times. And I can demonstrate that. Granted, we're talking about seconds here, but like it still does make a difference. So I can demonstrate this. So if I go to the config for this game, I have this as a macro. I can just flip on or off. So cd c dev manta boot.bat project equals vitality. I'm just going to use LLVM because it's faster. So if I clean the build, so this is a build with my trimmed header files. We'll see how long this takes. So this one took about 1.8 seconds. Maybe we'll run this a couple times just to get like, because now the compiler's hot and cached, so it's going to go faster. But it's about 1.7, 1.8. So that's with the trimmed header files, like my custom ones. If I just flip these off, I actually might get a compile error here. We'll see. I think there was something I need to fix. So we'll see if this works. Oops, I need to clean the cache. Yeah, so here it is using the official ones. And I have a compile error because, see, this is another dumb thing about the official ones. Here, let me fix this. So I'm getting an error because I'm using the keywords, the word near and far. And this is there's a header file that's just like stealing this word from me. So let me fix this really quick. See, look how dumb this is. This is stealing the word near and far. There's a header file in C. The min-win-def, a Windows header file, steals the keywords near and far as macros. So I never have to deal with this because I don't typically use the official ones. But let me just fix that. And we'll redo this experiment. So we can see it's taking longer already. So that took about 5 seconds, right? 5.4. Let's just do a couple runs for fairness. Like, it's still fast, obviously. Like, 5 seconds is fast. But you can see it takes about 5 seconds to compile with the official C header files. And if I flip those back off in this config to use my trimmed versions, can't type. Let me make sure we clean the cache. So if we turn those back off, 1.8 seconds. Yeah. So it's about a 2x, 2.5x improvement just in trimming the header files, which again, we're talking seconds. So it's not like, it's not mission critical, of course. But you can imagine as a code base expands, you know, it just gets, it gets that much worse. Have I tried cache? Yeah, I have. Or is C cache something else? Yeah, this is all just like self-taught stuff, I guess. I've just learned from trying to solve these problems. The internet is an amazing resource for finding information. So that's how I've learned, just using the internet. And solving things, it's like I have a problem and I'm like, okay, how do I fix this? How do I make this problem go away? And over time, you just do this with enough things and you kind of just learn a bunch of stuff. And that's how. So like if you want, like one thing I cared about significantly was compile times, right? So like how do you profile compile times is a good question. So like you can look this up, and this is a good example of like a good bit of knowledge if you care about this. So it turns out with Clang, there is a compiler flag called ftime tracing. So time tracing is a compiler flag that Clang accepts. And if that is given, when you actually compile the game, or compile with that flag, it will give you these JSON files next to the object files, which contain tracing information. So it contains timing information. And there's someone who has written a tool called ClangBuildAnalyzer, which is really, really convenient. So ClangBuildAnalyzer. There's this tool out here where basically it uses the ftime tracing flag, and this will like kind of glob them all together into a single understandable dump of information. So I can go into command prompt again and call this tool ClangBuildAnalyzer. Well, first I'll build this game. Project equals asteroids, toolchain equals LLVM, config equals release, clean equals 1. So this will build the asteroids game with the time tracing stuff. And then if I call this with, I think it is all, and I pass it the output folder of this. So wherever these JSON files are, basically. Reveal in File Explorer. Let me just copy the path to this thing. And I give the tool that path and then just like a capture.txt. It's going to compile that into a little capture, and then you can call this analyze and call this. So this gives you a little dump, basically, of the compile time for your project. So like, where is your compile time going? So you can see that this build took 2.2 seconds for parsing, 3.5 seconds for code gen. And I believe this is over all of the threads used. So the build was faster, but it was multi-threaded, so it finished quicker, but this is like the cumulative time across all threads. And then here's like a nice convenient list, like what files took the longest to parse. My object system file, which is like a giant translation unit. This one took a long time because there's a lot of code in here. Which took longest for code gen. So my math library took a lot of time for code gen, which is probably templates. STB image and TrueType took a long time as well, interestingly. Like here are the templates that took the longest to instantiate. So here are my vector types, which makes sense because these are in my math library, which had the longest code gen time. And then like what headers are most expensive? So my graphics header is the most expensive, taking 27 milliseconds per include, and there's included 19 times throughout my code that compiled. So you just get all this useful information. So like if you want to optimize your compile times, you'll just do something like this and just see what takes the longest, right? So like if I want to improve my compile times even more, it's like a good place to start would be, one, am I including GFX more often than I should? Because this is an expensive header. And two, is there a way I can make the GFX header like quicker to parse, basically? So that would be an option. I could cut down potentially a bit of time. And like, you know, it's just easy to kind of go through here and just figure that out. So like this is good information to have, I guess. But this is just something I discovered, I learned through trying to figure out how to make my compile times faster. So like no one taught me this. It's just I found this tool online and I was like, wow, this is pretty cool. And here I am sharing it because I think it's cool. And yeah, is it possible to cache libraries without recompiling them? Yeah, certainly. Most libraries you don't have to recompile. Like if you ever see on Windows you have like a DLL file, or I guess not even a DLL. Yeah, it's certainly possible to, like a DLL is basically a compiled bit of code that links into your, you can either dynamically link to it or you can statically link it at compile time or at link time. And then you only have to build like the DLL whenever you change it. So yeah, you can certainly avoid a lot of this if you like have a code base that you're going to use, but you don't need to compile it all the time. So yeah, that's definitely an option. Yeah, I'm actually not aware of the author. Does he have other stuff, or do they have other stuff, I should say? Because I don't know who they are. How do I get to like the actual page for this guy? Here we go. Oh, he has some HLSL to GLSL. Nice. He worked on the Unity game engine. Classic. Yeah, okay, so he's a bigwig. Nice. Nice. Yeah, that's cool. Yeah, I just found this through Google. I was like, is there a way to analyze Clang compile times? And this is a good resource. And this is the other benefit. See, people ask me this all the time. It's like, why do I support multiple C++ compilers? Why don't I just use MSVC with Visual Studio? It's like, the reason I support multiple compilers is because there's like this tooling. Say hello to the cat, everyone. Hello, kitty. The reason is that there's like these different tooling available to the other compilers. So it's like nice to be able to compile my code across, you know, multiple tooling suites, and I have access to everything. And that's basically why I do that. And why I advocate for other people to do that as well. But anyway, I'm probably going to wrap up the stream here soon. I know I said that a few times, but I I've been going for a while, and I need to go do other stuff with my evening. I should probably go work out because I've been sitting here for the last 8 hours. Oh, autism. Hello, cat. My cat wants me to stop as well. He's like rubbing up against the microphone. So, yeah, I will probably stream again on the weekend. Maybe Sunday. I'm not sure yet. Probably. We'll see. I might start working on the other game again, the Terraria clone, because I'm getting inspired to work on that. Again, hello, kitty. Goodbye, kitty. So maybe look forward to that. But yeah, thankfully we got some lighting stuff implemented in normal mapping. Let me make sure I commit my changes as well. I don't really want to commit the ClangBuildAnalyzer, but I guess I'll commit it. Model tangents. I think that's basically the only thing I did for the Manta. But yeah, all right. Thanks everyone for watching. I appreciate all the chat. Definitely fun. Yeah, I'll see you guys